Universitas Negeri Padang, established in 1954 under the name PTPG Batu Sangkar. UNP's vision is to become a reputable, internationally recognized university.
Assalamualaikum warahmatullahi wabarakatuh. I am Profesor Ganefri, PhD, Director of Universitas Negeri Padang. Welcome to Universitas Negeri Padang.
The impact of technology and the industry nowadays have triggered Universitas Negeri Padang to develop sustainable programs. Universitas Negeri Padang focuses on education and qualified teaching process, research and high-quality publication, then community services that give advantages to the society.
The campuses of Universitas Negeri Padang are spread across 7 areas in West Sumatra. Universitas Negeri Padang has equipped facilities and infrastructures, such as a main library with digital services, an auditorium with a capacity of more than 8,000 seats, swimming pools and sports fields of national and international standards, and laboratory schools from kindergarten to senior high school.
Hello everyone, nama saya Maria Adeline Doroin. I'm from Capiz State University, Philippines. It's worth to remember and worth to share to the world. Mabuhay UNP!
Other facilities include a medical clinic, international student dormitories, the UNP Hotel, a mosque, a business center, and a teacher education center.
from Myanmar.
We are studying in different faculties at UNP, and we are very proud to be international students here at UNP.
We love UNP!
In order to improve the quality of its graduates and be an international level university, UNP equips itself with laboratories supported by sophisticated equipment, a center for developing students' soft skills and creativity, as well as adequate practicum and training facilities.
Ladies and gentlemen, welcome to the hybrid conference. We will start the opening ceremony at 8:30 p.m. Thank you for your attention. Ladies and gentlemen, we cordially invite you to prepare yourself. The ceremony will begin in a few minutes. Thank you for your attention. International Conference on Chemistry and Science Education. His Excellency, Rector of Universitas Negeri Padang, Professor Ganefri, PhD. Honorable Vice Rector of Academic Affairs of Universitas Negeri Padang, Dr. Refnaldi. Honorable Dean of the Faculty of Mathematics and Natural Sciences, Associate Professor Dr. Zulkifli. Honorable Vice Dean of Faculty of Mathematics and Natural Sciences. Honorable Head of Department of Chemistry, Faculty of Mathematics and Natural Sciences, Associate Professor Budi Octavia, PhD. Respectable are keynote speakers in this international conference. Keynote speakers, Professor Dr. Ilyas MD Isa from University Pendidikan Sultan Idris. Associate Professor Muhammad Abdul Qadir Martoprawiro, PhD from Institut Teknologi Bandung. Professor Dr. Andri Rusdi from National University of Singapore. Associate Professor Anang Sedia Hutomo from Hamamatsu University School of Medicine. Professor Dr. Ana Permanasari, MSc from Universitas Pakuan. Professor Dr. Mawardi, MSc from Universitas Negeri Padang. Associate Professor Dr. Nur Hasniza Ibrahim from University Teknologi Malaysia. Honorable are invited speakers Dr. Tan Lingling from University Kebangsaan Malaysia. Dr. Muhammad Amin from Universitas Khairan. Ms. Trisna Kumalasari, PhD from Universitas Negeri Padang. Mrs. Okta Suryani, Master of Science, PhD from Universitas Negeri Padang. Dr. Pujan Novita, MPD from Universitas Negeri Padang. Mr. Habidin, PhD from Universitas Negeri Malang. And Mrs. Unit and Mr. Yunis Eka Putra, MPD, as a teacher in SMA Negeri 12 Sijunjung. Excellencies, honorable guests, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome to the 4th International Conference on Chemistry and Science Education. The theme of the conference is Science Learning in 21st Century, Upcoming Industrial Revolution 5.0, and Material Science Synthesis and Application. I am Unita, and I feel honored to be the master of ceremony for this conference. This conference is organized by Department of Chemistry, Universitas Negeri Padang. Ladies and gentlemen, the keynote session will be start at 9 a.m. until 3:40 p.m. Western Indonesia time. Ladies and gentlemen, to start the event, listening to the national anthem, Indonesia Raya. The audiences are pleased to stand. The audiences are pleased to have a seat. To express our gratitude to the Almighty God, I would like to invite Mr. Hardiansyah to lead the prayer.
Assalamualaikum warahmatullahi wabarakatuh. Let's hold on our head as to that Allah subhanahu wa ta'ala be his blessing for the issue of today's conference. Let's take a moment to our head together. Ladies and gentlemen, followers religion is other than Muslim. Please adjust this prayer to our own belief. And please let me lead this prayer in Islam ways. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين اللهم صل على سيدنا محمد وعلى آل سيدنا محمد. Oh Allah, today in Saturday, just 12 2022, in this such beautiful place, we gather here to hold international conference on chemistry and science education. Please let this international conference as a medium to share knowledge, idea, and beneficial experience for our life, to line our horizon, to radiate our thought, and to let us to become productive and successful men to live nation pride. Oh Allah, please assist and bless our heart and mind with your light and guidance. Please set your word for our activities and help us otherly help in order to listen compassionately, respect each other, love each other, so we belong to blessed people. Oh Allah, protect us from unwanted plans. So use the right things right the way they are, and wrong things are wrong. Use knowledge and strength to the right thing and avoid unpleasant ones. ربنا تقبل إنك أنت السميع العليم وتب علينا إنك أنت التواب الرحيم. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. سبحانك ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين. السلام عليكم ورحمة الله وبركاته.
Before the next agenda, please enjoy the performing arts. Tari Pasambahan.
sulam sari sara tujuh baju bakti kuntiang de anak raja onde kandang onde sana di dalam tari kami menyembah sama sendiri yang lanjut caranya onde kandang onde sana ya Tuhan berkata kata-kata dan dua himpunan puji tumbuhan sambal jawelah salam sarata sambal sambahan datang ya dari bawah adai teh kami ale mananti siaplah sirih gataklah pinang tak kalang hati ale mananti ekan doang oi pandai sana oi.
Ladies and gentlemen, welcoming speech from the chairman of the Fourth International Conference on Chemistry in Science Education. Please welcome Associate Professor Alizar.
Honorable Vice Director of Chemistry, Honorable Dean, Head of the Department of Chemistry, Chemical Science, we are especially honored by the presence of keynote speakers who have accepted our invitation to be plenary speakers. The first, Professor Dr. Andri Forsdi from Ministry Singapore. Professor Dr. Ilyas Matisa from Sultan Idris Education University. Professor Dr. Ana Permanasari from Ministry Pakuan. Professor Dr. Mawadi from Universitas Negeri Padang. Associate Professor Dr. Anang Sugiotomo from Hamatsu University School of Medicine Japan. Professor Associate Professor Dr. Muhammad Abdul Qadir Matro Prawiro from Institut Teknologi Bandung. Associate Professor Dr. Hasmiza Ibrahim from University of Technology Malaysia. Especially for Professor Dr. Ilyas Matisa, Professor Dr. Ana Permanasari, and Associate Professor Dr. Muhammad Abdul Qadir Matro Prawiro. Welcome to Padang and enjoy your time. Assalamualaikum warahmatullahi wabarakatuh. The first of all, thank you of Allah with Subhanahu wa Ta'ala, who always give health, blessing, and salvation for all of us, so that we can to be here with the trouble of all. Secondly, salawat and salam for Prophet Muhammad Sallallahu Alaihi Wasallam, who always give goodness in the world. Ladies and gentlemen, we need to inform to you what the 4 ICChSE is divided into parts, namely ICChSE E and D. The theme of ICChSE E, Material Science, Synthesis and Application. Meanwhile, the theme of ICChSE B, Science Learning in 21st Century to Welcome the Industrial Revolution 5.0. And also, I want to provide information to all of you that the selected article in this conference will be published in the proceeding that indexed by Scopus. And then I would like to thank all the international conference organizers who have worked hard to prepare of this conference, and also thank all participants who have attended this event. We hope with this conference we can share of information related to chemistry of education and chemistry of science. Besides this, I would like to thank to you all who have supported this conference. On behalf of NSCI Committee, I apologize if during the organization of the conference there are things that are less pleasing. Thank you for your attention and apologize for any shortcoming. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for speech by the chairman of conference. The next agenda, welcoming speech from Dean of the Faculty of Mathematics and Natural Sciences. Please welcome Associate Professor Dr. Zulkifli.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Honorable Vice Rector Universitas Negeri Padang, Vice Dean of Faculty of Mathematics and Natural Sciences, Head of Department in Faculty of Mathematics and Natural Science, Head of Graduate Program in Faculty of Mathematics and Natural Science, distinguished keynote speakers and invited speakers, organizers of International Conference and Chemistry, Science and Education 2023, dear participants, ladies and gentlemen. Good morning. First of all, I would like to thank Allah Subhanahu wa Ta'ala, who has been giving us blessing and mercies to we can attend this conference in good condition. Salawat and salam are always given to our Prophet Muhammad Sallallahu Alaihi Wasallam, who has taught their people respectively in order to attain happy and prosperous life in this world and hereafter. I'm delighted to have this opportunity to welcome you in the International Conference on Chemistry and Science Education 22-23, which is hosted by Chemistry Department, Faculty of Mathematics and Natural Science, Universitas Negeri Padang. We are especially honored by the presence of eminent keynote speakers. We have graciously accepted our invitation to be plenary speakers. Professor Dr. Andri Forusdi from National University of Singapore. Professor Dr. Ilyas M.D. Isa from Universitas Pendidikan Sultan Idris, Malaysia. Professor Dr. Ana Permanasari from Pakuan University of Indonesia. Professor Dr. Mawardi from Universitas Negeri Padang, Indonesia. Associate Professor Dr. Anang Sedio Hutomo from Hamamatsu University School of Medicine, Japan. Associate Professor Dr. Muhammad Abdul Qadir Marto Prawiro from Institut Teknologi Bandung, Indonesia. And the last speaker is Professor Dr. Nur Hasniza Ibrahim from University Technology Malaysia. And to all speakers and participants, I'm greatly honored and pleased to welcome you to this online conference. This conference is especially occasion for those who work in chemistry, science education, and other related fields. The ICChSE will be a media to meet, share information, find partners for future collaboration, exchange new ideas, and application expression. Hopefully, this conference will contribute to innovation and trend in material science and science learning in 21st century field, and to meet the challenge of fifth industrial revolution. I also wish to express my gratitude to organizing committee and the science committee for their diligence. Finally, we respectfully request the Vice Rector of CSD Padang to open this ICCchSE 2023. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for the speech by Dean of the Faculty of Mathematics and Natural Sciences. Ladies and gentlemen, welcoming speech and opening from Vice Rector of Universitas Negeri Padang. Please welcome Dr. Refnaldi.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah rabbil alamin. Wassalatu wassalamu ala asrofil anbiya wal mursalin wa ala alihi wa sahbihi wa rasulillahi ajma'in. Asyhadu an la ilaha illallah wahdahu la syarikalah wa asyhadu anna Muhammadan abduhu wa rasuluh wa nabiyya ba'd. Very good morning, distinguished guests, ladies and gentlemen. The Honorable Dean of the Faculty of Mathematics and Natural Science, Universitas Negeri Padang, Vice Deans of the Faculties of Mathematics and Natural Science, Department Heads, keynote speakers and invited speakers, and also committee of this conference, and all participants. First of all, allow me in this opportunity to welcome you all in this conference. by first praying to our grateful and praise to the Almighty God for all His blessing, grace, and mercies that have made us possible together here in this room in very good condition and health. Dear keynote speakers, distinguished guests, and participants of the Fourth International Conference on Chemistry and Science Education. So this event is held by the Department of Chemistry, Faculty of Mathematics and Natural Sciences of Universitas Negeri Padang. Representing directors of Universitas Negeri Padang, I'm very pleased to join the opening of this hybrid conference. I wish to convey my sincere appreciation to the head of chemistry department who has regularly held the conference. And this year is the first conference. And this is also the first conference series in the Faculty of Mathematics and Natural Science in 2023. And I'm sure that 4 other conferences will proceed to this conference this year, from Mathematics Department, from Biology Department, from Physics Department, and even from Natural Science Department. I would like to thank all the distinguished speakers for taking your time to participate here in this conference, especially in the first conference. Professor Dr. Ilyas Muhammad Isa from University Pendidikan Sultan Idris, Malaysia, who has come here on spot. Yeah, thank you, Professor. Professor Dr. Ana Permanasari from Pakuan University, Indonesia, who has been in this room. Thank you, Prof. And Professor Dr. Mawardi from Universitas Negeri Padang, Professor Dr. Muhammad Abdul Qadir Marto Prawiro from Institute Teknologi Bandung. So thank you for taking time to participate in this conference, Prof. Professor Dr. Andrifo Rusdi from National University of Singapore, and Professor Dr. Anang Sedio Hutomo from Hamamatsu University School of Medicine, Japan, and also Professor Dr. Nur Hasniza Ibrahim from Malaysia. I believe that this conference will become a good medium opportunity for us to learn, to communicate, and to share newest information about the knowledge, concept, and theories, as well as the result. And the most important things are to create networking and to cooperate, as well as to collaborate with the international experts, as well as institutions in the international level. Through this conference, it is expected that we can improve the quality of our research as well as innovation and the trends for their global challenges. Distinguished guests, ladies and gentlemen, please allow me to talk a bit about the current teaching of chemistry. So it is generally known that students find chemistry as a difficult subject. Chemistry is not just highly abstract in nature, but also get even more challenging because it requires not only scientific skills, but also mathematical skills. This perhaps add more to students already burdened mind with scientific concepts alone. There is certainly a need to be more innovative teaching to help students understand, learn, and appreciate the subject. Scientists tend to use mental images and to use multiple representations of the phenomena when solving complex problems, and they can switch from one representation to another. Conceptual understanding in chemistry requires the acquisition and the integration of multiple representation at three different levels. Macroscopic level is the most concrete levels of representation. Microscopic level is an intermediate level of representation on the concrete to the abstract scale. And symbolic level is the most abstract levels of representation. Chemical educator believe that students truly understand chemistry only when they can successfully use these three levels of representation and when they can see the links among them. To understand the complexity of this subject, students need to be supported with learning tools that would help them see and understanding the relationship of these three conceptual understanding. Many recent developments have focused on the internet and the World Wide Web. The internet has made a huge impact on the way chemists work, but most importantly, the way this discipline is taught. The internet provides vast and varied services that can be used in the teaching of chemistry. The exchange of information is one of the key aspects of the internet. There are many developments in the use of internet since its development that are slowly being introduced within education. Recently, educators have been encouraged to overcome the inertia of the traditional school lab report and adopt new ways to enable students to communicate their environmental outcome. Instructional design to incorporate technology with the aim of enhancing and learning environment should be applied to enhance student-centered activities while improving the flow of tasks and student engagement. Modern teaching techniques is seeing more and more implementation in chemistry education on the use of mobile, web, and e-learning techniques. Mobile phones, especially smartphones, are becoming ubiquitous, especially in the hands of our students. Students and teachers are already spending a lot of time on mobile devices, coupled with amazing chemistry apps. These gadgets are powerful and convenient educational tools on a mobile platform that could potentially encourage learning. ICT revolution has significant impact on all kinds of human activities, as well as educational and training activities. So it could be said that the ICT assisted education may become a personalized and adaptive experience, especially among learners. It is used as a tool for designing new learning environments, integrating virtual models, and creating learning communities. Teachers in this modern era has to face the challenge and opportunity of utilizing modern technologies in their classroom. And with this, they need the support of the system to carry on this challenge of to meet the demand of and current needs of the 21st century learners. Ladies and gentlemen, internet together with smartphone, tablet, laptops are powerful tools for obtaining a lot of information, which offer a variety of electronic teaching materials, videos, electronic presentation, educational programs, animation, augmented reality, games, animations, simulation of processes, open online courses, learning texts, discussion forum, and list of links, and many more applications. However, it is found out that it is not always easy to introduce the use of internet in a meaningful way in education. Technological, pedagogical content knowledge framework as an approach for teachers as well as students to successfully introduce technology into learning activities. Technological pedagogical knowledge means that we understand the way technology influences the learning process. Developing TPK implies that we realize the potential benefits and the drawback of using particular technology in the learning process. Technological content knowledge deals with the way technology play a role in the development of content knowledge in the subject being. In most science subjects, newly developed technology plays a major role in research. Technological pedagogical content knowledge is the intersection of it. It is a type of professional knowledge that technological adept teachers use. It combines the pedagogical content knowledge that teachers have with insight in which technology can play a role in the learning process of the student. These teachers understand the ways in which concepts are best introduced to students and are able to use technology to help students understand the content better. Therefore, there is now a need to support not just teachers' pedagogical knowledge, content knowledge, but in this modern era, educators' TPA-CK or technological content knowledge is a present area for teachers' development. Having this knowledge make possible for the successful utilization of modern technology in teaching and learning process. There is the modern teaching technique. So distinguished guest participants, ladies and gentlemen, representing the academic staff, administrative staff, and students of Universitas Negeri Padang, we'd like to thank all speakers and participants for your contribution, which will make this conference a success. Who could have imagined a better exchange than seeing invited speakers from several countries here joining forces in the conference to share experiences, research findings, and inspiring ideas. And the most important thing is having opportunities to learn many things from each other. We expect we learn new ideas from the speakers that we can adopt and adapt for further improvement in our work in research. I know that there will be many interesting and useful presentations, and I believe good experiences will be shared and good lessons will be learned. Members of organizing committee have been working very hard. I'd like to thank you all for your dedication, time, and effort. I wish also to thank our patrons, individual and organization partners, as well as volunteers. Without your generosity, would not be able to create a total environment to support the full participation. Thank you for your presence and participation. And you are the very important part of the conference success. So please enjoy the conference. Ladies and gentlemen, by saying Bismillahirrahmanirrahim, the fourth international conference on chemistry and science education is officially open. Thank you. Wabillahi taufik wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for the speech by Vice Rector of Universitas Negeri Padang for officially open this conference. Ladies and gentlemen, this is the end of the opening ceremony. We are glad that you have a chance to attend till the end. Before continue to the keynote session, we would like to introduce our first moderator today, Mrs. Okta Suryani, Master of Science, PhD. She received her doctoral degree from Tokyo Metropolitan University, Japan, in 2018. Ladies and gentlemen, please welcome Mrs. Okta Suryani, Master of Science, PhD.
Kurang.
Bismillahirrahmanirrahim. Thank you to our MC, Miss Yunita, for the kind introduction. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Honorable Vice Rector of Academic Affairs, Universitas Negeri Padang, Dr. Resnaldi, and Honorable Dean of Faculty of Mathematics of Science, Dr. Yulkifli, Honorable Head of Chemistry Department, Universitas Negeri Padang, keynote speaker, distinguished participant, and ladies and gentlemen, I am Okta Suryani. So much pleasure to welcoming you here to the 4th International Conference in Science and Chemistry Education with the theme Material Science, Synthesis and Application. Talking about material, there are abundant materials that have been developed. In this occasion, we will talking about quantum dot and another material. And here we have 2 keynote sessions already. And before we move on to the main talk, let me to explain the rules in this session. This talk will be divided into 2 sessions. We are having outstanding researchers on their field of keynotes with us already. The first speaker is Professor Dr. Andri Forusdi from National University of Singapore. And the second is Associate Professor Muhammad Abdul Qadir Marto Prawiro PhD from Chemistry Department of Institute Teknologi Bandung. And we have 45 minutes for each part, include 35 minutes of talking by lecturer and then 10 minutes for Q&A. And the participant who have a question could send their question to the host via chat room in Zoom application. And the participant who already in this room could raise your hand for the question. Okay, let's welcoming our first keynote. We have Professor Dr. Andri Forusdi already. And hello, Professor Rusdi, are you there? Hello?
Hello, yes, can you hear me? Hello?
Hello, yeah, I can hear your voice.
Okay, very good.
Yeah, in the room, there's still, how about the connection in the room? Is it okay?
Yeah, I can hear you well. Thank you.
So much. Halo, Assalamualaikum Prof. Rusdi.
Waalaikumsalam warahmatullahi wabarakatuh.
How are you there? We hope you here with us. We hope you pulang kampung, but however, yeah, this is the condition right now.
No problem. I think we can make use of the best of it. Don't worry.
Yeah, thank you.
Inshallah.
And let me to give a brief introduction first to the audience here. Okay, Professor Rusdi, expertise in the condensed material physics, quantum physics, synchrotron radiation, and their application for novel technologies. And he has published over 250 papers, including in Nature, Science, Nature Physics, Physical Review Letters, Nature Communication, advanced material, applied material, and a lot of journal that very interesting over here. And Professor Rusdi was born and grew up in Padang. He did elementary school at SD PPSP IKIP Padang, junior high school at SMP Negeri 2 Padang, and senior high school in SMA Negeri 2 Padang. He then merantau and received Bachelor in Science in Physics from Institute Teknologi Bandung in 1998, Master of Science and PhD in Physics from University of Groningen in Netherlands in 2001 and 2006. With most of research conducted at Brookhaven National Laboratory, USA since 2000 and since 2007, he has served as a researcher and lecturer at the National University of Singapore. I was a visiting professor at Center for Free Electron Laser, University of Hamburg, Germany, and since 2017, he holds world-class professor from Kemenristek Dikti of Indonesia, being placed in several universities in Indonesia. And we are pleased to have Professor Rusdi today. Professor Rusdi will be sharing with us his expert opinion on quantum physics and the foundation of our today and future technology. So with that, I ask all of the participants, I ask that all participants to give you full attention to Professor Rusdi and help me in welcoming him to the virtual stage. Professor Rusdi, please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Bisa terdengar
wabarakatuh.
Okay.
Bisa terdengar, Pak.
Okay. Bismillah. Today, first of all, I would like to thank the organizer, especially Professor Alizar, and also thank you for the chairman, Professor Okta, to provide the very detailed introductions. We focus today how quantum physics, which is actually also our foundations of today's and future technologies. This is my own experience, how I try very much focus on to understanding to bring Al-Quran, especially Surat An-Nur 12 to 35. And as presented, you can look at our publications. We have published already over 250 publications, including Nature and Science. And if you look at today's surrounding us, everything is based on the quantum physics, including what we have today that we discussed through Zoom and technology used today, cell phone, and also your computer, for instance. So basically, the point of this light is for this An-Nur 12 is actually light-matter interaction, how photon interact with matter, and the matter here is spin, charge, orbital, and lattice. So it takes a lot of effort, and it's all my research. I bring up everything. My interests always come from Al-Quran. So today we look at one part of the ayat, how we bring the future technology based on the transition metal, also including, for instance, I give example, gold. The ayat you can look at, for instance, the best of the ayat that we look at it is Al-Insan 76, 15 to 16. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم ويطاف عليهم بآنية من فضة وأكواب كانت قوارير من فضة قدروها تقديرا. This ayat challenge, it took me 20 years to understand this ayat, and alhamdulillah, the understanding of these ayats is actually bring us into so-called Hamiltonian, where we have to understand, I have to understand how Hamiltonian apply to wave function of a particle, and this particle can be spin, is charge, orbital, and lattice, and that actually bring us into energy, and this is where we come to technology. So if we are able to actually write down or having the correct Hamiltonian and then having the correct energy, it will bring us to important technologies in this case. So what would be the important technology? So the question is that from this ayat, Allah subhanahu wa ta'ala is telling me that I should be able to change gold that you see every day, which is yellowish color and opaque, become completely different what we have every day. So if you look at the today's gold, it is noble elements, yellowish color, opaque, which is not transparent, metal, and non-magnetic. Yeah? So this ayah telling me that I can change the structure of material. I can make the material become extremely different than natural material itself. So before we come to the gold, I give you example that how we bring this technology into other material, for instance. So I give you example what we did in my class. Give me a second. Let me change the share. We make two ices. Okay, we make two ice. One ice, oh, sorry. A simple ice, but we make the ice completely different. One ice we make with a regular ways in terms of just put them into a cold refrigerator. Then I ask my student to smash the ice, yeah, this regular ice. So this student that we have is going to smash with a hammer, and this you have to have the safety. So every experiment that you do, you have to have the safety and the glasses, and see how many heat that she has to do in order to break the ice that we make regularly. Right? So let's have a look. Warming up. 1, 2, 3. 1, 2, 3, 4. Very good. So basically, with regular ice, yeah, we can smash it. Yeah, with very easy, we can break the ice into pieces. Now, take a look. What if I use the technology, nanotechnology? In this case, what we just have learned from the ayats. If we make the ice completely in terms of changing the Hamiltonian. So I ask again my students. So one moment. Okay, the student that we have. This time I make sure the student is a strong one. So two gentlemen here, you can see from the muscle, yeah, very strong muscle, and see how the student can break the same H2O. But this time, remember, we follow the Hamiltonian in Sun 15 and 16. We just seen. 1, 2, 3, 4. Even with the two hands, he's not able to actually break the ice. Yeah? Now, to make sure this is actually strong enough, I asked my second student, which is definitely also very strong. Let me show you one moment. Okay. Yeah, you're able to see the correct slide now? Yes. Okay. Take a look the second student. You can see the muscle is very strong, and I make sure that the student come to the gym every day, so then have enough energy to smash the ice. Take a look. So now you can see that understanding of the Al-Quran, we can even make ice become extremely strong and not easily being crushed by a hammer, for instance. So what does it mean? It means that this ayat already have the correct application, if I understand how the particle actually interact among each other, we can make even ice is extremely strong, stronger than regular iron, because we can smash them and nothing happens. Okay, so this ayat also helped me to develop my own lab. What you see here is that we are going to show you how to make the gold transparent. So we're going to use so-called synchrotron radiations, and the synchrotron radiation itself is actually a particle that electron accelerating with the speed of light and generate photons with an extremely broad energy range. So we take, for instance, atoms. So we have to look at periodic table. This is where chemistry plays an important role, and we take one of them, so-called gold. So the gold, we're going to make a piece of the gold, so layer by layer of the gold. But this time, we have to be able to control precision of the atom of the gold, which is defined by NUR 35, what we just learned previous few minutes ago. So we already showed to you how the demo, we can change particularly the ice become extremely strong, right? And then we can also show you that the material that we can change, that is all chemistry plays one role here. We can change the color of gold, but this time the color of gold is even more exciting, because we are going to make the gold become in the future become a biosensor, for instance. So what technology that we aim to from this ayat? So if you look at the photonic technologies, we have a lot of technologies today based on the quantum physics. We have the AM radio, we have FM radio, mobile phones, radar, microwave, ultrasound. This all based on the quantum physics. And then even all the way to look at optics, bioimaging, and that's going to the X-ray. We have medical X-ray, cosmic ray, imaging, and crystallography. So what is missing is actually these regions. You see here there's a lot of technology not being developed yet. This is a gap we have to fulfill, and the lab that we have, that we present to you, is to have technology, new science and new technology in this region. So we aim to pioneer and create novel technology based on deep UV and soft X-ray regions. So what do we want? Why this part is so important? The reason for this is so important is that because the range that we are covering based on this ayat are in Sun 15 and 16. We want to detect, for instance, we want to understand bacteria. We want to detect viruses. We want to detect protein, DNA, for instance. This is all very important. That's in our life. And water molecules, even water that we just showed to you, we can make water so strong. There's so many mysteries that we don't understand it yet. And also novel technologies based on spin, chart, orbit, and lattice. So there's a lot of so-called technology based on these two ayats already itself. But it takes a lot of effort to understand, because we have to go through a quantum physics. Now, the last part of it, the ayat itself helped me that I have to understand energy quantization. So the fact that you see color today, the fact that you can see me even we are far a distance, that is quantum physics. So I welcome you all that you are now living in the quantum world. So anyone that want to create new technology in the future, we must understand quantum physics. So the atoms and how the atom interact among each other is plays one role, where we have to understand so-called electronic structure. And the electronic structure that we have to be able to control atoms. That means we have to be able to control the size of the energy of these particular, for instance, atoms. Remember, we want to make gold become transparent. This is not straightforward to do. Okay, so we also have to learn so-called orbitals. So all these things is a physics and chemistry and material science and engineering plays one role together. So it's no longer just one particular subject. So this s orbital, there's a p orbitals, and there's a d orbitals, and etc., etc. Okay. So the last part, the third part, that we have to understand the electronic structure, where we have to be able to tell apart how the energy of this material. Remember, once again, the idea is that how we can make this gold, which is yellowish color, is no longer yellowish color. So I must understand this part, because it's already from the ayat itself. So now we come to the point. Can I modify the nature of the gold We just learned, okay, yellowish color, opaque, metal, and non-magnetic to become something no longer yellowish color, something that transparent, no longer metal, become insulator, for instance, and also gold become magnetic. If I can do that, that means I'm in the right direction to understand Al-Insan 15 and 16. Now, indeed, Alhamdulillah, we managed to make that material gold become transparent. It takes there's a lot of excitement day and night. We have to think. You see this material, the new gold that we created is no longer a yellowish color, but something else. But not only that, they become transparent. If you look at, we place a piece of paper in the back side. Okay, the white paper looks green color, while the black paper can be seen like white color. We can even change color. What happens behind the transparent gold is not, so it's actually manipulate everything behind it. So we can see this is actually this new technology. We also have the patents for this transparent gold. You can take a look at this, but also we have to realize that this technology are actually interested by industry. So we collaborate with industry. Industry want to understand how the gold become transparent, because soon enough, we're going to see around us a lot of technology, a lot of things is based on gold or transition metal itself. So you have to understand, we have to understand how to make gold transparent. In this case, we have to understand crystal structure. Today, we are not going to have the detail of this, but I just want to tell you that with the technology, the technique that we develop in our lab, we can put atom by atom precisely. We can define the distance between the atom, and we can tell them apart, like making the highly oriented single crystal quantum dots. It's a new type of material. Okay. And then everything based on equations. So the translation from the Al-Quran is not about word to word, but it's going to equations. So we have to look at the structure factor. We have to look at the position of the atom and how gold become transparent with the different color itself. Now, the last part that I want to show to you is that how we use this gold to detect. This is actually how we look at the gold, individually gold. They are really ordered among each other, and the size can be so precise to pack it, and how they packing each other give you a different orientation, also different transparency or different color of the gold. So everything, it comes together. And this is where we have the new optical properties of the gold. And we also understand why the gold becomes transparent. Also, what's the gap of the gold, and also making the gold is no longer non-magnetic. We also find the gold become so-called magnetic. So you can see today, yeah, the gold is non-magnetic, but soon enough, you will see gold today, the gold technologies is best become like magnetic material. So the last part, we also test the gold, the transparent gold, and impressively we make a new detections biosensor. Yeah, this is what you see here, the transparent gold, and we place bacteria on top of it. Even E. coli, we are able to detect that based on a new phenomenon, so-called chiral plasmon, and that is not possible if we only use regular gold. So regular gold, everything, all these bacteria and virus will be together with that, but we are not able to detect it. So it's actually not good for our health in the end. So the last part in this case, that we aim to make the technology based on this quantum, based on this transparent gold. This is just the beginning of the new era, and you can see, hopefully it motivated you that we are living in the quantum world. So let me summarize what we just learned today. This is what we presented today. First of all, the Al-Quran teaching me in this case, that I should be able to make gold transparent after 20 years, 30 years of understanding of Al-Insan 15 and 16, and also An-Nur 24 and 35, An-Nur 35. And alhamdulillah, we can make gold become transparent, and we are able to control them, and having gold is no longer yellowish color, but any other color except but yellow, we can make it. And now we can also have new properties of the gold. Yeah, so if you have now gold in your hand, and then or your fingers, and you want me to make it transparent, you just let me know. We can make it transparent for you, and it will make the price of the gold drops dramatically, because it's just like glasses, right? So, and also note that we can also make the gold become detections, a new detection for viruses and pathogen. So for that, I would like to close, and thank you very much for listening.
Thank you, Professor Rusdi, for the nice talk and very interesting. And for the participants who have a question in this room, could raise your hand and I will deliver the question to the Professor Rusdi. Okay, let's continue in the chat room. We will check. Okay. Okay. Maybe I will start from the question from me, Professor Rusdi.
Go ahead.
So
Yes.
I want to ask about the gold nanomaterial. You said that the color of gold is changed after a modification in the I really interesting about that. So I want to know what happened with the gold, that why it's changing, the color is changing to colorless. So that's very interesting. So I want to know the detail about
All right.
that.
All right. So if you want to know the detail, it's not difficult. Are you familiar with the quantum physics? Are you familiar with this equation that we put from the beginning? Let me show you.
Okay.
One moment. Are you familiar with these equations? One moment. Give me a second.
I have seen this equation, but I need to study about that, I think.
Okay. So if you want to know detail, you go back to these equations. Without this equation, it's unlikely we understand it. So this equation itself is actually the tafsir from Al-Insan 15 and 16. So this is the Hamiltonian. So this actually, you can use this equation for other to make gold become different type. It's the key is the H. H is the technology. Okay, H is the technology, and this gives you the energies or the outcome of the technology. So equipments, you have to make the equipments that is H, and then the outcome becomes like this, the right side here. So you have to calculate the energy. So everything has to come in the correct energy calculations. And then you can make gold becomes different color. Okay, and then if your gold, if you see the gold become transparent, do you like it? If I make your gold become transparent like glasses, do you like it? You don't like it, right? Because that means gold.
I cannot say that I like it or not, but this is very interesting because
no, I don't think. Take a look glasses. Take a look glasses in front of you. Okay, so I can make your gold become just like glasses. You do not see the difference between regular glasses and transparent gold anymore. So that means the price of the gold can be actually reduced dramatically, so, just glasses.
Yes, exactly. Yeah. So I worry about the seller of gold in Pasar Padang.
It will go drop. Price will go very low.
Yes.
And that's the idea.
So another question, if we use this question for the this equation to the molecule, I mean organic molecule, how do you think about that? Is it
You
on
have to look at electron. Molecule is not sufficient. You have to look at electron. So these wave functions apply to individual electrons. So you have to apply that, and you have to put the electron into the correct orbitals, which is 6s orbitals.
okay.
And then you create atom by atom. So you don't create molecule, but you create quantum dots. But the quantum dot has to be ordered precisely. So it's so much detail. So if you start from today to think of how to make gold transparent, inshallah, 20 years later, you will make it.
Yeah.
Okay.
I'm working in organic molecule, but if we're talking about electron in organic molecules, a lot of electron over there. So it should be placed very exact place. You said that.
Yeah. It has to be exact place, correct. It has to be exact place, it has to be the correct orbitals. And that's what we just learned just now. The energy has to be correct, because when we change the energy, and that means we also change the properties of the material. We can change it, human can change it. Allah give us permission to do everything in the entire world because of the Al-Baqarah 30. وَإِذْ قَالَ رَبُّكَ لِلْمَلَائِكَةِ إِنِّي جَاعِلٌ فِي الْأَرْضِ خَلِيفَةً. Because of that, I can tell electron to move into different orbitals. Okay, so hopefully that motivate you. There's so much can be done, but you have to focus. You have to consistently think over day and night for that. Otherwise, it won't work out, because it has to be precise. Okay, and you have to go to the lab, and then you have to show that every equation must fulfill the right condition into the reality. So Al-Quran telling us today that we are living in the quantum world. It's not classical world. So if you want to understand how things work with light, you go back to the quantum chemistry, you go back to the quantum physics, and then enjoy from that point. Hopefully that helps, yeah, to everyone.
I think I study more, not only organic, but also quantum dots from. Okay, another question from the participant. Okay, Pak Miftah, please.
Okay, thank you so much, Professor Andri Korsti. We are very happy, and your presentation is very interesting for us. Especially you can relate Quran verses with your quantum physics findings. And you just talked about gold. And we have known so far that gold has been used for currency for a long time ago. And now it is also the standard of the currency in the current era. My question is, based on your finding, will the status of gold can be used as currency in the future? Will the price will increase or even decrease? This is my question. Thanks so much, Professor.
Okay, that's very good. The fiqh might be changes because of this. Okay, the fiqh of that gold completely different now, because dinar that Allah stated in the Al-Quran is not the same thing here. So I want to point out that if you see transparent material, price is cheap, right? Because we know it's silicon dioxide. Now, if I put two transparent material at the same time, people would not notice anymore why one is higher the price than the other one. So the currency of the gold, even though the gold is a noble material, but since we are able to make them a different color and everything in the future, the properties of the gold is more toward technologies rather than you put in the bank because of this black chunk of gold. So surrounding us, we want to have the gold become a solar panel as well. So that's why gold become, Allah himself stated, become so important for our life. It's not because of the saving per se, but rather than being useful for everyday's life. Okay, not just style of Professor Okta for the wedding and put gold everywhere. That's not really useful anymore. But rather that, hey, we're gonna use gold to detect viruses in your food, viruses in your drink, for instance, or bacteria, or even what is this, for wudu. to define suci, air yang suci. Thus, we can use transparent gold. And it's actually very, very powerful because Allah Himself stated in the Al-Quran. So it's up to us how to realize that in terms of technology. So that is the real amal jariyah. Because in the future, everyone technology will use it, and then in the alam barzakh, we just enjoy it because everyone gonna use it. And that's beyond. That's why we have, as a Muslim, we have to write papers, because papers will actually stay until Qiyamah, inshallah. But without paper, nothing happened.
Yes. Thank you, Professor Rusdi and Miftah. And we have another question here, Prof.
Yeah.
From Miss Bernadetta Ayu in the chat room.
Yeah.
Professor, I have a question. Is it the transparent gold has luminescence? I see your slide before that you applied it to biosensor. So it is, so how about the property?
Oh, that's very good. Yes, they do have now a different, some kind of luminescence, because the gold that we make today is no longer metal, but insulator. To be specific, it's rather mud insulator. So this opened a new era in terms of luminescence technology as well. And this is what I mentioned. If you like to have the research along this luminescence, this open a new field itself. And there's a lot of luminescence that you might want to have to develop the gold quantum dot itself with different size, so you can control the luminescence energies itself. And that itself is important for technology. And again, it's based on gold. Okay, so you purchase next time gold, but you aim it for technology, and that is more useful. Okay, so after this talk, I wish to have Professor Okta to pass over her gold. We make it transparent for you, and it's no longer price is dropped dramatically, and then you'll be happy.
Everything becomes transparent.
Everything becomes transparent.
So I'm thinking that is it kun faya kun everyone? Yes. So for Allah, everything can be changed drastically. Very easy.
Yeah, we can change it because of the Al-Baqarah 30. If you don't want, if you cannot change it, that's simply because we don't understand Al-Quran. So the fact that we are able to change it, that means we start to understand Al-Quran. That's what it means.
Thank you so much, Prophet. And another question, I see another Professor Rusdi in the slide. Any question, Pak Rusdi? He is smiling over there. Okay.
That's a real Rusdi.
Say
Yeah.
hi, Pak Rusdi. Okay. Another question from the participant. I think we are in the end of the session, Professor Rusdi, and I'm still amazed with the gold material become transparent right now.
Alhamdulillah. How about the eyes? You should be amazed over the eyes too.
But
we can make the eyes very strong, and then we can make the gold extremely soft.
Oh, really? Because gold is yellow, right? So I'm very amazed about that. Okay.
Good.
Thank you so much again, Professor Rusdi. And we would like to deliver the certificate of appreciation to Professor Rusdi. The committee, please. Okay. Here is the certificate of appreciation to Professor Dr. Andri Fauzi as the keynote speaker on International Conference on Chemistry and Science Education in 2023. Once again, thank you so much. We hope we will meet you in person in Padang. Yeah. Again, we hope you will pulang kampung maybe Yeah, next time.
Amin.
And we will talk about quantum physics more detail.
Ya
Yeah.
Allah.
Again, thank you so much, and hope you have a nice and day today. And Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, ladies and gentlemen, we move on to the next session. We have Associate Professor uh, Muhammad Abdul Qadir. I'm sorry, Pak Kaka, because uh, we always call you Pak Kaka, so this is difficult for me to uh, call your name very precisely. Let me try again. Okay. Now, let's welcoming our second keynote speaker. We have Associate Professor Muhammad Abdul Qadir Martoprawiro, PhD, with us, as known as Pak Kaka again. And please welcome Pak Kaka. Let me to read a brief introduction. Okay, Pak Kaka received a bachelor degree in chemistry in 1987 and master degree in 1990 from Institute Technology Bandung. During his master, he engaged as a lecturer and researcher in chemistry department, Institute Technology Bandung. And he continued his studies at the University of Sydney, Australia in 2005 until 2007. He appointed as executive director, and in 2009 until 2017, he was appointed as a chair of master program in computational science, Institute Technology Bandung. In 2018 until 2022, he appointed as chair of academic program in chemistry department ITERA. His expertise and also in quantum study through computational study. And now we have Pak Kaka here for the his current research about current quantum mechanical approach in the study of reaction mechanism. So, ladies and gentlemen, please welcoming Pak Kaka.
Jadi ngomong di sini langsung masukkan ke Zoom. Okay, thank you for the time. Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. I would like to present title of current quantum mechanical approaches in the study of reaction mechanisms. Next. Yeah, this talk about research on reaction mechanism computationally. There is a three parts. The first part is a review of our research, and the second part is about current methods, and then how to use the current methods to do research on reaction mechanism efficiently. That's the second part. So that's about strategy to do research, and then the search new tools that we develop. In 1994, we only used Hartree-Fock method in our first calculation. Okay, and did computation with beta method after that first method using MP2, MP4, perturbation method, G2, MP2, and etc. The methods called post-Hartree-Fock. In 1998, the editor of Journal of American Chemistry, it's not American Chemical Society. This is Journal of the Physical Chemistry A, actually. Asked us to try density functional theory. So that's the first time we try density functional theory. And in that year, for the first time, computational chemists got Nobel laureates. Two chemists got Nobel laureates in computational chemistry. 2020s, we started using parameterized quantum calculation to find transition state with low computational cost before accurate computation with DFT or density functional theory. This review will discuss the strategy for research on reaction mechanism using the latest tools, the latest method. Okay. At the end of the presentation, new computational tools for experimentalists will be introduced. So in the future, not only physical chemists and theoretical chemists will use computing tools, but also organic chemists, inorganic chemists, biochemists, etc. Okay, next. The first class review. Yeah, next. Before, next. Yes. Okay. For simple molecules, we can use ab initio methods. That's very it's not called traditional because it is quantum mechanical, but the methods that use in the beginning of study of reaction mechanisms. I already tell you that in 1998, John Pople and Walter Kohn were awarded the Nobel Prize in Chemistry. So at that time, my article have been requested to do that method also. And 2006, also there are many new functionals to study here, to study this. For example, MO62X from University of Minnesota. So that's the development of the methods from 1990s to 20. Before I continue my talks, I would like to remind you about energy diagram reaction. You know that if we have a reaction, this is the reactants, this is the products. If it's exothermic, the energy diagram will be like this, and then endothermic like this. You know that already. But from reactants to product is energy barrier. So the challenge of computational chemists is to find the transition states, because the reactants and the products can be isolated experimentally and then do, for example, X-ray diffraction, etc., and then we know the structure. But we cannot isolate the transition state because it will go to here or to here. So the transition state structure can only be determined by computational methods. And if we find this, we can know the barrier and then what steps that easy and then what step is difficult, etc. So that's the role of computational chemistry to study reaction mechanism. Then next, this is our first article in Journal of Physical Chemistry A in 1999. Before this, we submit articles since 1994 to Chemical Physics Letters and etc. discussing only one part of the steps of the mechanism. Uh, in this article, we use ab initio methods. Ab initio methods is the methods that very computationally expensive. We have to wait for several days to calculate and etc. And next, yeah, this is just an example that we got about the pyrolysis of pyrrole. This is just one channel in chemical physics letters. One channel. There is many channels to go through these results. Okay, and next, the previous research are reactions on gas phase, in gas phase. So there is no solvents, etc. But if we do calculation on organic reactions that involve nucleophile or electrophile, we know that electrophile it's more stable in water, for example. So we have to calculate the effect of solvents. For example, in this one, without solvents, the barrier is very high, but with solvents, it's lower. Next, in the next page, I will discuss this one. Next. Okay, this is one of the research of my students, synthesis of flavanone from chalcone. This is zat anthramense intermediate. This is transition state 1, and then this is transition state 2. I will discuss these two to discuss solvent effects and stereoselectivity. Next. Okay, this is the transition state 1. This is the transition state 2. We can see that from the reaction in the previous page, we can see that the transition state 1 is very polar. Okay, that's good. Okay. The first transition state in the reaction mechanism is very polar, but this one is non-polar. We can see that we can computationally calculate the effect of solvent. For the first transition state, that's the polar one. In the gas phase, the barrier is this high. But in the water, in the ethanol, which one is ethanol? Ethanol is one, I think. Methanol is probably here also, this one, the blue one. And in toluene, this one. So we can see that in the polar solvent, the activation energy is drop. But in the second steps, in the gas phase and also in the solvents, the activation energy is similar. Why? Because it's non-polar. So we can predict the effect of solvent. Next. That reaction also can explain why the reaction is enantioselective. We can see that the mechanism toward air flavanone is through this intermediate, but toward S flavanone through this intermediate. This one is the distance. This is the distance between this aromatic cycle and then this one. This is the distance. We can see that this is closer than this one. And experimentally, this one is more stable. I mean, in the reaction, the result, the yield of this is higher than this one. So we can explain why this is so. It's because the intermediate is stable because of pi stacking. Pi stacking in this article, Hoynen et al. In 2008, Journal of Chemical Theory and Computation, they said that pi stacking only occurred if the distance is less than 4 and 5 angstrom. So we can understand why the one product is a higher yield than other product. Next. This is another my other student research. Next, just skip. This is more no piraver. It's about what is this? It's the drug for COVID-19. But I don't. I will not explain this. Next. This is another my other students published in Russian Journal of Inorganic Chemistry in 2019. We went into the research on polymeric complexes. Is very computationally expensive because expensive or not depends on the amount of electrons in the compound. If we study organic reaction, it's cheap because carbon is only 6 electrons, nitrogen only 7 electrons, hydrogen 1 electron, etc. Even chlor is only 17 electrons, but iron is 26 electrons. And this is polymer complexes. So many ions, so very, very expensive. We can study here not only reaction mechanism, but also spin cross of spin transition, temperature of spin transition. Next. This is just this is from my student that just graduated next month, not just graduated. Okay. We study about single atom catalyst, Suzuki Miura cross coupling reaction. So in recent years, there is a new catalyst, not only organic catalyst or heterogenic catalysts, for example, solid state catalyst, and then go to nano catalysts. In experimentally in Japan, for example, they do research on single atom transition metal catalyst. Jadi single atom, not solid, not nano. And we can explain the mechanism that proposed from by experimentalists in the top one using palladium, and then we predict how if we change the palladium to nickel. Okay, I will explain this if time allows, but next page. Okay. Okay, let's see. Yeah, okay. From those research, we can learn for the future. First, there is an order of difficulty in computational research. Structure is very easy. We can predict structure with lower level of theory. But in that level, the energy is not accurate. For accuracy in energy, we have to go to the better level of theory. And then to find transition states, we have to use more expensive and difficult theory. And then for spin-related properties, that's very, very difficult. For example, to predict the transition, what spin crossover complexes, and then at what temperature it change from low spin to high spin. That's very the last article that I explained is about spin related properties. For DFT, density functional theory, don't choose functionals based on popularity, because for example, one article in journal said that B3LYP is best method for organic molecules. And then after that article, almost all organic chemists use that functionals. But later, they said that B3LYP only good for stable structure, not for transition stage. So that's one that we have to care about. Yeah, okay, understand the chemical system based on various aspects. Partially filled 3D orbitals, homo-lumo gap, molecular flexibility, and etc. That's many aspects that we have to consider in computational chemistry. Read articles from leading figure about practical aspect of DFT. This is a suggestion for experimentalists. Read articles from, for example, Stefan Grimme, because they don't only explain about the difficulty in mathematics, etc., or Schrodinger equation, etc., but the practical aspects, how to solve real problems in organic chemistry, in inorganic chemistry. One example, how to explain why gold that is yellow becomes transparent. For quantum physicists, they will explain by Schrodinger equation, Hamiltonian, wave functions, and etc. Okay, but a chemist will explain like this. In gold, the electrons can go from one atom to another. That's called metal bonding. Okay, metal bonding is the electrons go from atom freely transfer from one atom to another. So the movement of the electron is delocalized. Like, for example, another example, butadiene. It's transparent, or that's color or apa bening apa transparent ya. Kalau bening apa bening? Colorless, okay. Colorless or butadiene is colorless, but carotenoid is orange. Yeah. Why? In butadiene, electron only go from one pi bonding to another pi bonding, so the resonance is limited. But in the carotenoid, it go from one end to the other end. So it's the UV gap between HOMO and LUMO becomes lower. So from UV becomes orange. That's from butadiene to carotenoid. It's also from gold to transparent gold. Gold is the localized electron is moved from one end to the other end. But if we make a gold that nanoparticles, and then the nanoparticles join to other nanoparticles using van der Waals bonding. So the electron only move in one nanoparticle. They cannot go to another. So this becomes localized, not delocalized. So the difference between HOMO and HOMO becomes higher. UV. So becomes transparent. So that's another explanation from a chemist, not from quantum physicist. Okay. Next. Okay. Now, learning for the future. The ab initio method starts with Hartree-Fock method, followed by Hartree-Fock method that I explained before. That's the method that used before 21st century. So up until the end of the 20th century, that's the method. In 1990s, density function theory with lower computational cost than ab initio method has shown greater accuracy for determining transition state. So we got cheaper methods, lower computational costs with higher accuracy. That's density function theory. This in 1990s. And next page. In the early 90s, initial efforts were made to develop a density functional tight binding. It's different with density functional theory. Densital functional tight binding. That's the new method for molecules. This method previously used by physicists for solids, not for molecules. And then chemists take the method and then change it and use it for molecules. This method is classified as semi-empirical approach, but our group calls it parameterized quantum calculation because semi-empirical approach, the past generation of semi-empirical approach is not accurate, but this semi-empirical method is, accurate enough. Okay. In 1995, the first DFT method called DFT1 was introduced by Stephen Grimm and colleagues. In the mid 2000, I think it's about 2005, various DFTB methods that were better than the FTB1 emerged and were applied to the study of reaction mechanism with reasonable accuracy. So we examine how to combine the DFTB methods with the more accurate but more expensive density functional theory with the aim of making research more efficient. Next. Okay, so strategy for research on reaction mechanism. It is difficult to find transition states by predicting the structure and then optimize the structure towards saddle point. We call transition state as saddle point. It's difficult. For example, one of my students in his research, he only could find the stable structures from reactants, intermediate 1, intermediate 2, intermediate 3, and products, but cannot find any transition state. But 1 month before he graduated, he find one, and then following weeks, the second one, the third one. Yeah, very difficult, but if he got the tricks, he can find, and then after that, he went sandwich to Groningen and then accepted as in doctoral program, and then after that go to America, Japan, and then Islandia, etc. And after until now, he's still there, still in overseas. Okay, so this is the strategy. The strategy is first step, use parameterized quantum calculation to scan the energy surfaces. So the good aspect of the parameterized quantum calculation, because it's very cheap, we can not only find one structure, but can go from reactant to product and then scan the energy surface and find the transition states. And then after that, second step, find the highest energy in the path for the first prediction of TS, but this is not as accurate as density functional theory, but very fast. And then after that, optimize the transition set by density functional method, the more expensive one. So that's the strategy for future research. For example, this is one example. This is the method for that accurate for stable structures. B3LYP, or better from this, B3LYP with dispersion correction. So it called B3LYP space D4. That's better. So this is cheap. For example, to optimize a molecule in this level of theory, we need, this is about the previous research that I explained, 1 hour, 8 minutes. If we improve the wave function, this is theory, this is wave function. This is the level of theory or functional, we call it. This is a wave function. If we change the wave function, it needs 15 hours. If we use the functional special for transition states, again, this is for good for stable structure, but this is good for transition state. It needs 18 hours. But we can combine this and this. First, we optimize by this method first to find the stable structure, and then re-optimize using this. So this one only need 7 hours. So total, this is 1 hour and 7 hours becomes 8 hours. So we can do first do with lower level of theory, and then re-optimize. So it's less than half and from this. But next page, let's see. Okay. Okay, let's see what. No. This is, bisa ke sebelumnya. Halaman sebelumnya. Nggak jalan, ke berikutnya bisa.
Yang slide berikutnya.
Sebelumnya.
Oh, sebelumnya.
Slide sebelumnya.
Slide
Okay.
sebelumnya.
Okay. This is density functional method, but let's see. This time only for one molecule. Only for one molecule. This is for one molecule. But if we use parameterized quantum calculations, it's not accurate, but we can do scanning from reactant to product, several structure, only less than maybe 15 minutes. So the strategy is, if we use this method, we have to predict the structure of transition states and optimize, and sometimes fail. But before we do this, we use this method, scanning the potential energy surface. So we can understand the reaction mechanism quickly, better than before. Okay. Okay, reaction involving radicals. By radicals, there is possibility that triple state has lower energy than single state. So it's not always single state more stable than triplet state. Sometimes. So triplet state more stable. So we have, for biradicals, we have to check both. Okay, I can skip this. Just go to here. For solvent effects, the suggestion is avoid purely electrostatic models like Cosmos, CPCM, etc. In the journals, it's very popular, but don't use that. Alternatives is in the order of quality is SMD, Cosmo RS, D Cosmo R. Experimentalists should read about different approaches in calculation of solvent effect when they enter computational work. So that's the suggestion. And then third part, new tools. Okay. My student that right now associate professor in Waseda University, and also my former student, I mean, one is a lecturer in computational science in ITB, one is a lecturer in UGM, and etc. Join one team to develop this one. You can see, let's page to know about this software. In the about page, from about page, CMMDE, Computational Molecular and Material Design Environment, is a set of tools based on Python for running computational jobs, as well as analyzing, visualizing, and post-processing the results in free and open source applications for computational molecular and material design. Why we develop this? Because if we use the open source software in computational chemistry, the method is very, very difficult. The procedure is very difficult. So we develop this to, let's see, the next. Nah, this is next. This is this software developed for decreasing the barrier in using popular open source computational chemistry software. Currently, CMMD can use the following software: Orca, DFTB+, GROMACS, DOCS, DC, DFTB MD, Quantum Espresso, XTB, Open Bubble, etc. About CMD, a set of tools. This is the one that I explained before. So the goal is to decrease the barrier in using popular open source. So we developed this, and then in next January we will there will be a workshop online to use these tools to explore organic chemistry, the properties of molecules, the reaction, the mechanism for inorganic chemistry, to check what more stable, the triplet state or single state, the high spin or low spin. For example, for ammonia ion complex, the more stable is the low spin. Yeah. And for the chlor complex with ion, is the more stable is the high spin. But for another ligand, we can check which one is stable, and then find the transition temperature from low spin to high spin. And we can also do research on, for example, crown nectar, some structure to put in metal, for example, etc. So next, this is apart from the command line procedure, we provide also the web-based application. So we can just create molecules here and then click user information, put your name there, and then molecule information. For surface chemistry research, we can also click surface builder to create surface, and then click main calculation to do calculation. For example, to optimize structure and then to find energy and etc. And then post calculation to calculate frequency, for example, and etc. And then predicts the infrared spectra or UV spectra, etc. So in one web page, we can use many software behind that. So that's how we develop. Okay, that's all. If sorry, the conclusion. Okay. Computational chemistry or quantum chemical calculation can be used by experimentalists to improve the quality of research. Stefan Grimmel. Yeah, from Stefan Grimmel. Stefan Grimmel tell us that 3 workshops of material science to understand matter at the atomic and electronic structure level is first chemical synthesis. You have to have skill in chemical synthesis, and then spectroscopy to understand, to characterize, etc. And then quantum chemical calculation to predict and to explain what we know and to predict the future. Practical aspect of computational chemistry should be accompanied by basic understanding of the principles, even without theoretical complexities. So we can understand without theoretical complexities. Strategy of research on reaction mechanism start with parameterized quantum calculation, improve accuracy with dual-step DFT methods that I explained before. CMMDE is to simplify the use of computational tools. That the developer is we can see. Coba ke halaman CMDE lagi. The developer. Nah, this one. Core developers. This is associate professor in Waseda University, is lecturer in ITB, computational science, not chemistry, computational science, but S1, his S1 is chemistry, but right now it's computational science. Hasan is in Kanazawa University, me, and this is in UGM, contributors and etc. Okay, that's all. Thank you very much.
Okay, once again, please a big applause to Pak Kakak. Okay, we continue to the Q&A session. Any question from the participant? Please mention your name.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Jan Henry. I'm from University of Bandung. That's inilah. I speak to Dr. Kaka. I say the short name because that's my friend. That's the time in the ITV I with Prof. Iman Susanto. That's a very difficult one for me. That I got only a C grade, not like Kakak. Okay, this is interesting. I'm also physical chemistry, but quite different with Dr. Kakak. That's I interest for enzymatic catalyst. That's a catalyst is very easy to know how to the energy to become transition state to make from reactant to go to product. That is transition, like you explained this morning. But this have used organic and organic organic. But it's difficult for me. Until now, I don't know for biochemistry how to use the computing calculation from an enzymatic catalyst, because we don't know sometimes the structure and how to calculate the energy with the theoretical. Can you give us the suggestion? Because right now I'm interesting. My research in fermentation. Fermentation is used for enzyme. From we don't know the enzyme structure yet, but we can. Now that's if we like a graphic for enzymatic catalyst, they have some stationary state and the lag state. The lag state is how the adaptation of microorganism. How to solder to catalyst become if we know the energy. Right now we just use the genetic engineering to engineer two species or catalyst. Okay, that can you give me as advice for this?
Okay.
Thank you very much.
Okay. Yeah. Very interesting question. Before the use of parameterized quantum calculations, we can use ab initio methods for small supercomputer. For example, in ITB, about 64 CPU, for example, we can study molecules up to puluhan atom, up to 90 atoms, for example. But it's heavy. It's difficult for 90, probably 50, 40 atoms. Using density functional theory, we can go up to 90, for example. Using ab initio, maybe only 30, 40. Using parameterized quantum calculation, we can do calculation for example, 20,000 atoms using the last methods. Because why? Because we do calculation for small molecules, get the parameter, and use that parameter to calculate the big molecules. So we don't calculate from zero for big molecules, because we do calculation for small molecules first, and then get the parameterized quantum parameters, and then go to that. The opportunities is very big. For example, up to now in Indonesia, study for enzyme, for example, for proteins, usually use docking methods. Docking methods means the molecules is rigid, the protein molecules, but the substrate, the ligand is flexible. The single bond can rotate and etc. But the protein is rigid. In reality, the protein is not rigid, okay? Because when the substrate move closer to the protein can change its shape, for example, okay? So they improve the method using molecular dynamics, but molecular dynamics is plus Newtonian mechanics. Only they can only study the interaction, intermolecular interaction, hydrogen bonding, van der Waals interaction, hydrophobic interaction, etc., but not reaction. But the parameterized quantum calculation, we can do like this. First, they move closer, and then calculate the stable structure because of the hydrogen bonding, etc. But the method can calculate the strength of the bond, the hydrogen bonding, not because of the electrostatic interaction, but also polarization, because they can calculate how the electrons, the density of electron change. And then after that, we can give potential to go to other structure and then react, give some potentials. We call it meta dynamics methods. Give some energy and then let the ligand and the protein move to the high energy and then find the path to go to the product. One of my doctoral students will, for the first time in Indonesia, use that methods, and then will graduate it in October. So again, current methods only docking for interaction, but the protein is rigid, or molecular dynamics, the protein is not rigid, but only intermolecular forces, not reaction. But using parameterized quantum chemistry, we can calculate, give some potential, some energy to find the saddle point and then go to product. So that's the future of enzyme, computation of enzyme. And for Indonesia, we need some skills. First, that's computational skills. Second, X-ray diffraction for protein. Tidak ada di Indonesia. So to find the structure of protein using X-ray diffraction and put it in PDB, no skill. If we have these two skills, we can, for example, study the thermophilic enzyme in microbes in kawah volcanoes. Yeah, and it's usually enzyme will stop working in 40 degrees or 50 degrees, but for thermophilic enzyme can work in 90 degrees, for example. So we can develop industry using that enzyme to produce beneficial molecules. So that's the future. But we need some researcher that can determine the structure and then becomes our kekayaan kita. But yeah, okay, that's all.
Okay. Okay. Another question from the participant. Okay, if not, let me ask one question, Pak Kaka. So, actually, I'm working in organic to synthesize organic molecule to split water, because to split water to hydrogen. So the organic molecule working as photosensitizer. Okay, and in the reaction of synthesis, I use a Suzuki-Miura coupling reaction. So you said that you study about the possibility of using nickel, not palladium but nickel. So I want to know, because palladium is too expensive, this is difficult to synthesis in our laboratory because lack of funding. So I want to know about the result about using nickel.
Okay, yeah, palladium is very expensive but good catalyst.
Yeah.
For catalyst in the macroscopic level, solid and surface catalyst, palladium is better than nickel. Also in nano catalyst, but in the single atom, for some steps of mechanism, if we use surface nickel and palladium, palladium is better because it's lower the energy activation energy, the barrier. But in our calculation, if one single atom, nickel is better, but it's only some parts, some steps of mechanism. We have to check the other parts, but it's yeah, promising. Probably we can use cheaper transitional metal to do Suzuki Miura and other other reactions. Yeah.
Okay. So I will try nickel later. And another question, the last question is, because I'm using organic photosensitizer to anchoring to titanium. So titanium. Yeah.
Okay.
And actually I'm working in DFT calculation as well. And I'm using B3LYP, but this is difficult for me to calculate the interaction between organic molecule and titanium. So I want to.
Yeah.
There's
Okay.
question for me.
B3LYP is very popular, as I said. Many organic chemists said that B3LYP is good for organic molecules, but the drawbacks of that functionals is there is no correction for dispersion. So it's good for pi bonding, sigma bonding, and etc. inside the molecules, but it's not good for first for transition states. Secondly, for intermolecular interactions.
Okay.
So for interaction between molecule and titania, you should add D3LYT at D4. There is D3, D2, D3, D4. It becomes better and better. D4 is the best one for dispersion correction. So the interaction intermolecule is becomes better.
So maybe next time I want to discuss with you about the matter. So maybe ladies and gentlemen, and we are in the end of this session. So thank you so much, Pak Kaka, for the discussion about the computational study of transition state of reaction. And now we would like to deliver the placard from committee and chemistry department to Pak Kaka. And please Pak Budi Octavia, PhD, to deliver this placard to Pak. Okay, the photographer, please. Please take a good picture. One, two, three. Okay, thank you so much. For the certificate will be delivered to Pak Kaka later after the this is the copy, but the hard copy will go to you. So ladies and gentlemen, this is the end of the second keynote session. Once again, please give a big applause to our keynote speaker, Pak Kaka. Okay, I am Okta Suryani. This is the end of my time. So thank you so much and see you again.
Thank you, Mr. Okta Suryani. For the second moderator, Mrs. Hesti Parbuntari, Master of Science. She received her master degree from Universitas Gadjah Mada in 2016. Ladies and gentlemen, please welcome Mrs. Hesti Parbuntari, Master of Science.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Thank you, Ms. Sunita, for introducing me. Before we are going to the next keynote presentations, I would like to remind you the rules or the mechanism of our Q&A sessions. Because here there are two kinds of participants, the on-site participants and online participants. For the online participants, you can use chat features in our Zoom platform and send your questions. And then if you want direct interactions to our keynote speakers, you can use raise hand features. Then our committee will give you opportunity to deliver your questions. And then here for the on-site participants, if you have a questions to our keynote speakers, you can raise your hand and then our committee will give the microphone to you, or you can come closer to the podium here, the stage here. Then our committee will give you the microphone to ask your questions. All right, ladies and gentlemen, for the next keynote speaker, please welcome Professor Ilyas Matisa. Assalamualaikum, Professor Ilyas. Good morning. How are you today? I know that this is not your first time coming to Indonesia, especially to Padang.
Yeah.
And I heard you have a delay for your airplanes.
Yeah.
But I really hope that you will always enjoy come here, and we will always welcome you. All right, ladies and gentlemen, before we listen to our keynote presentations, I would like to read a brief biography of our honorable keynote speaker, Professor Ilyas Matisa. He is a professor of analytical chemistry at Department of Chemistry, Faculty of Science and Mathematics, University Pendidikan Sultan Idris, Malaysia. Actually, I already came to the University Pendidikan Sultan Idris professor when I was in my bachelor degree. But it was really a long time ago. I think it's 2010, more than 10 years ago. Yeah. And then he achieved his PhD in analytical chemistry from University Science Malaysia. His research interests including bioscience, biosensor and chemical sensor, wastewater treatment, environmental and electroanalytical chemistry. He is a reviewer of reputable journals. And then he is also a Malaysian level grant assessor, also was appointed as a grant evaluator for National Science Center, Poland. He also appointed as International Technical Program Committee for Conference on Sensor Device Technologies and Applications, sensor device from 2016 until now. Our keynote speakers, Professor Ilyas Matisa, will deliver the presentations, give a talk about chemical and biosensor based on layer hydroxide nanomaterial. Are you ready, Professor?
Yeah.
Yeah. For the time of presentations, maybe about 20 to 30 minutes. Ladies and gentlemen, please welcome Professor Ilyas Matisa.
Assalamualaikum warahmatullahi wabarakatuh. Thank you to MC. First, I want to thank to the committee of the conference to invite me as a keynote speaker. Today, I want to share my experience in chemical and biosensor, and the title is Chemical and Biosensors Based on Layered Hydroxide Nanomaterial. Okay, normally we have several or many instruments can use to determine analyte. Analyte mean chemical. Normally we use UV, ultraviolet, or visible, IR, infrared, atomic absorption, inductive copper plasma, luminescence, to determine, or we want to check what analyte in the sample. Sometimes we can use separation method. We use chromatography, like gas chromatography, liquid chromatography, electrophoresis, okay? Separation method to determine the analyte. Our field, and we use electroanalytical method to determine the analyte. I use potentiometric technique and also voltammetric technique. Next. Okay, these are the various instruments in chemistry. We ready. This one is it's fluorescent, spectrometry. One is HPLC. This GCMS. This UV visible. Okay, next. This common instrument we use to determine or to detect chemical. Okay, next. Okay, for that, the instrument we use to determine, normally we determine organic sample or analyte. So this one is mercury analyzer. This one is ion chromatographic, anion and cation. We can use this instrument to detect, for example, chloride, ammonium. Okay. This one is atomic absorption, and the last one is ICChSE. All the instruments we have in UPSI. Okay. When we have also NMR, nucleus magnetic resonance, to determine the structure of normally we use for organic material, and also we have FCSAM, and to see the figure, what you see what the what? Efficient. You see, sorry? Yeah, yes. Scanning electromagnetic scope. I see. Yeah. And also we have XRD. XRD. Okay, this instrument we can use to determine the structure, also the chemical. Okay, next. Okay, I use electrochemical method, especially for potentiometry and voltammetry, but they have another three method, conductometry, colorimetry, and also dielectrometry. Okay, I'm only doing 2 potentiometric and voltammetric method. Okay, these are advantages. Why I choose or my group choose electrochemical method. Okay. Was one, allow for the determination of different oxidation state of an element in a solution, not just the total concentration of the element. Okay, why this method is very special? Because we can measure, for example, iron 2 plus and iron 3 plus. We can differentiate iron 2 and iron 3. When we use ICP or atomic adsorption, we only measure the total of iron in the sample. It's very special for electrochemical method. Okay, provide analyte species exhibit electroactivity, can be oxidized and reduced or oxidized or reduced. Then it may be detected using the tool of electrochemistry. Okay, I can explain after this. Capable of producing exceptionally low detection limit. This is the another advantages. Sometimes HPLC, ICP, AES, maybe until nanomolar, but when we use electrochemistry, we can detect until picomolar. Provide abundance of characterization information, including chemical kinetic information. When we measure with EIS, electrochemical impedance spectroscopy. And the last one is low cost technique, friendly user, stable, good sensitivity, and reproducibility. Okay, we can see there. Next. Okay, we can see the limit of detection when we use electroanalytical method. Okay, this one is 10 power minus 16 molar. The power of the electrochemical analysis. Okay. For example, we detect RNA, also argentum, antimony, okay, until 10 power minus 13 molar. We use sweeping voltammetry method. There are various of voltammetry method. Okay, next. Okay, we show first potentiometric. This is a easier method to measure the electroanalytical method because we use only 2 electrodes. First electrode is working electrode and the second one is reference electrode. Okay, easier. And this potentiometric, we measure the voltage, voltage of the reaction analyte and working electrode. Okay, the other electrode, the reference electrode is used Normally we use AGCL electrode or hydrogen electrode as a reference, and also we use the open circuit cell potential using a simple device like pH meter. pH meter. We can use pH meter to measure the voltage of the reaction. Okay, very cheap, very cheap. When the reaction occurs, so we can measure the voltage. Okay, next. Okay, this is the type of voltammetry. There are the various type of voltammetry, either cyclic voltammetry, pulse voltammetry, stripping voltammetry, linear sweep voltammetry, and also chronocalorimetry. Okay, next. Here, this is the theory of the voltammetry. You can see from voltammetry, measure the current independent of applied potential, and the resulting current versus the potential will be plotted as a voltammogram. Okay, we can see here, when process oxidation and reduction occur, so we can see the cyclic peak here. This one is anodic peak, and this one is cathodic peak. For IUPAC, we call anodic upper and cathodic lower. But USA, United States, claim the upper one is cathodic and lower one is anodic, different. Between IUPAC and America. This is the example of square wave voltammetric. We can see here. They have two peaks. Means this voltammogram can detect two analyte. Every peak, one analyte. You see, this one is two peak and show that they have two analyte. And the analyte, okay, the analyte, we can measure the current of the reaction, okay, interaction between electrode and analyte. Okay, we can see the difference of current here. Okay, difference of current. Normally, the current are proportional to the concentration. Okay, concentration. Okay, this next. Okay, this is the various of voltammetry. This one is cyclic voltammetry. This one is pulse or stripping voltammetry. This one is the figure of the linear sweep, and this one is chronoamperometry. So the different voltammetry also give the different type of the voltammogram. Okay, why we choose next the voltammetry? A very simple method. Very simple method. We have three electrode. Okay, the main electrode is working electrode. Okay, the main method is working electrode. Here we have three counter electrode. Normally we use platinum or aurum electrode, and reference electrode. We can use argentum, or we coated argentum with AGCL. Okay, so we can make a complete system, and we connect to the potential state. Okay. Then we have the software here, software for voltammetry. Okay. Easier to develop the working electrode. Easier to develop. Okay, next. Okay, we have several working electrode because in electroanalytical the working electrode is very important, very important. If we get a good working electrode, so we can determine many of the molecule of chemical. For example, we can see that here chemical modified electrode. In chemical modified electrode include they include skin pring electrode, where we coat our conductor with active chemical can interact with the analyte or molecular imprinted. Molecular imprinted. Okay, all electrochemical sensors are based on electrochemical processes that occur at the electrode surface. So that the important is how we made the working electrode. The electrode surface modification plays an important role in the development of electrochemical sensor. Okay. Other purposes of chemically modified electrode are to enhance this important to enhance the analytical performance of the electrode by increasing the selectivity and sensitivity of the electrode, or by shielding the surface of the electrode from undesired reaction. Also, the modifier mean the active material also improve the ability of electron transfer to or from analyte, improve some chemical activity. Okay, how we develop the electrode, working electrode. Okay. Modified electrode can be prepared by several different techniques, such as we put a derivated chemical, polymer coated, functionalized, and electrostatically bound electrode. Okay. Most frequently, the layer of coating of electrode surface is electroactive. So mean we must add the electroactive ingredient as the working electrode. It can enhance or exchange electron with the underlying substrate material and be oxidized or reduced. Although some application of non-electroactive film. Okay, next. Okay, in my research or study, we use LDH. It's a nanomaterial. Okay. Among one of nanocomposite, which is organic clay, we call LDH, organic clay, LDH. LDH containing various metal cation and ion. Also LDH also have good catalytic activity and absorption property. Okay. The using of LDH also we can use in catalyze, adsorbent, ion exchange, catalytic support, flame retardant, polymer activity, and also corrosion inhibitors. Okay, this one is layered metal hydroxide. Also, cotton dop material also can be used as the active material in working electrode. Okay. Next. Okay, this picture or figure of the layered metal hydroxide. You can see positively layered material and positively layered material, and between the two positively layered material, we insert interlayer anion. So interlayer anion can react or can interact with the analyte and give the current or voltage, value of current or voltage. Okay, this one how we prepare the LDH. Okay, the the most important for this study, every synthesis of LDH, okay, we also can produce the user of the LDH as a chemical sensor. When we synthesis one LDH, so after that we can use as the sensor. So meaning if we synthesis 10 LDH, so at the last we can produce at least 20 article. Either normally we publish in Q1 until Q4 lah. Okay, this is a figure of LDH. I can see image FSM and the SHARTEM. Okay, the next example. Okay, next. Okay, next. Okay, what next? Okay, why we use LDH? LDH have rusted attention due to their specific lamellar structure, easily prepared and cost-effective, huge surface area. This is very important because huge surface area, good thermal stability, biocompatibility, low toxicity, and high mobility of analyte, chemical inertness, and remarkable anion exchange capability. Okay, the important of the electron article. Okay, we have the anion exchange. Okay, anion exchange can interact with the analyte and give the current or voltage. Okay, this is the application of LDH. We can use in catalysis, electrochemistry, photochemistry, pharmaceutics, biomedicine, ion exchange, and environmental application. And the using of LDH is very wide. And we only use in electrochemistry. Okay, in my research and our team, we only we all use carbon paste electrode as the working electrode. Why we use carbon paste? Because the electrode easier to prepare, And the founder is Norman Adam, 1958. But the carbon paste electrode still using until now. And every year, more than 1,000 publication use carbon paste electrode. Okay, carbon paste electrode easier to prepare. We mix carbon powder with a binder, and after that we add a little bit of an active ingredient. Next. Okay, next, please. Okay, how to prepare? Very easy. It's a CNT, carbon nanotube, paraffin oil, and a little bit of LDH. After that, we mix, we insert in the Teflon tube or glass tube, okay? And we connect to copper wire. And after that, we connect this copper wire to the potential state. Very, very simple method to develop a working electrode. Okay, next. Okay, from LDH, our group published more than 30 papers in I journal. more than 30 papers IDH as the active ingredient as a electroanalytical sensor. Yes. Today I want to discuss only several. For example, bisphenol A. Okay. Bisphenol A is a toxic ingredient. Sometimes we use bisphenol A in making a plastic or baby bottle, uric acid, propamine, acetophenophen. Okay, this organic material, and this one is inorganic. Vitamin mercury, copper, and cobalt. Okay, next. Okay, this the chart to produce the the sensor. First, we must produce the develop the electrode working electrode. Okay. Okay. Before that, we characterize first the IDH. We can use several chemistry instrument. Okay. This one is the electrochemical characterization of electrode by EIS and also CV. So that electrochemical response of analyte, optimization of experiment variable, chronocolorimetric studies, linear range, and limit of detection, reproducibility, repeatability, and stability. And last one is real sample analysis and validity study. Okay. Okay. We validate our method with commercial instrument such as HPLC, ICP, OES, AES, etc. Because why we must validate? Because we want to confirm that our sensor is a good sensor. Okay, first one is definition of nanomolar of mercury. So this is the cyclic water battery. We can see that before we add zinc, aluminum hydroxide, 3,4-methyl methoxyphenyl propionate. We can see before we added we can find anodic and cathodic peak. After we add a little bit of LDH, here we can see the peak here. So that the LDH we can use to detect the mercury. This is an example. Next. Okay, this is the parameter condition we must measure before we continue or before we confirm that the electrode or the sensor can be used as the good sensor. These are several parameters. Next. Okay, next. Okay, this one example. Okay. And this one we can see. This one is a different active ingredient. We mix in the electrode, and then we can see the different value of current. Yes. After that, we can see here. Yeah. Maybe this what you can see in the figure one, this figure 2%. 2% of the LDH can improve, or can give the higher current here. So after this, we use the 2% of LDH in the electrode. So this the parameter we use also this. We use pH. We must confirm the pH. After that, electrolyte. Okay, next. Okay, next. Okay, the scan rate, okay, also the scan rate of the satellite photometry or analytic sweeping. Okay, next. Next. Okay, this the linear range, the working range or linear range. We can see we have two linear range. Okay, here and here. Okay, we can detect until 10 power of 9 and negative 9 molar. Okay, better than AAS, better than AAS, atomic absorption. So mean that this better is better than atomic absorption spectroscopy. Next. Okay, we also use electrochemical performance. We can use EIS to measure the electrochemical performance of sensor, where we can get the surface area of the sensor, also the kinetic study. Okay, this one is a different method we use to we compare our method to the another method. Also use diffusion pulse, square wave, analytic sweeping, electron, ion selective electrode, square wave, and fluorescent sensing. Okay. You can see there the limit of detection for the our sensor is until 10 power of minus 9 molar. Okay. So that method is equal to mercury analyzer, because we compare our result with the mercury analyzer and reading acceptable. Okay, the second one is also we use the LDH, second LDH, okay, to measure the mercury, also mercury, mercury. Okay. Okay, next. Okay, this is the mechanism. What happened to the surface of the electrode when oxidation or reduction occur? We can see there. We can see this at the surface when we insert our electrode to the solution. We can see that. Yeah. First one is mercury 2 plus. Yeah. Change to this is in aqueous. After that, at the surface, okay, at the surface, mercury and LDH, okay, go to the process reduction. Okay. After that, reduce again. So the moving of electron can produce the current. So we can measure the current with this system, oxidation and reduction of the mercury. Okay, thanks. Okay, this example for determination of copper, ion copper 2 plus. And you can see there, if we don't insert any LDH, no current, peak of oxidation, also reduction. Okay, next. These are some parameter. Okay, normally we validate. This one we validate with ICCOES. ICCOES. So the result is also acceptable. Next. This one is COBAP. COBAP over 2 plus. Okay, next. Okay, this one we measure organic compound. Some organic compound we use to detect. We use LDH to detect some organic compound like docamine, acetylphenolphthalein, bisphenol A. Okay, next. And this is also the parameter here. Okay. These are the figure of the analytic stripping. Analytic stripping voltammetry. You can see here. We have three peaks. Different chemical have a different peak. We detect three chemical here. So tripic. Okay. Next. It is a example of the mechanism. Okay. This one is oxidation process. Yeah, oxidation process from OH. Okay. Change to what is phenol alcohol to ketone. Okay. Process oxidation. Yeah. So this one. Okay. So this process can produce a current. So we can measure it. Yeah. Okay, next. Okay, we also compare to the another what the throat. Next. Okay, this one the nanomolar of hydrazine. Okay, hydrazine. We use the zinc layer hydroxide 3,4 methoxyphenyl propionate. Okay. Next. Okay, thank you. Then okay, this is our collaborator. We can see from UMP, yeah, collaborator. And this one, this Prof. Shanta from Jogja, and I forgot this one from BRIN, Badan Research Indonesia, head of Nano Center. Yeah, center. Okay, thank you.
Right, thank you, Professor Ilyas Mat Isa. Now we are going to Q&A sessions. Ladies and gentlemen, if you have a questions, here from the on-site participants, do you have a questions for Professor Ilyas? Oh, okay. Miss Cisna?
First of all, let me to introduce myself. My name is Rina Kumalasari. I am a lecturer of Universitas Negeri Padang. Nice to meet you, Prof. Yes. Actually, this technique new for me about layer double hydroxide. So recently in my research, I have developed a sensor for detection of formaldehyde using nanomaterial-based glassy carbon electrodes or pencil lead electrode. So whether the layer double hydroxide technique can be used to immobilize on glassy carbon electrodes or pencil lead electrode surface for formaldehyde detection, Prof. Thank you.
Okay, thank you. Normally, we can use LDH to send formaldehyde because formaldehyde also have functional group, and LDH also can have a functional group, and we already made
For
the
formaldehyde
aldehyde.
detection.
Yeah.
Oh, so this technique can be used to organic and unorganic material.
Yeah.
Okay. Thank you very much.
We have various type of analyte, include formaldehyde
Okay.
in our group. Okay, because I choose only several analyte.
Hopefully we can collaborate.
Yeah. Because we have several type of LDH. Maybe we can collaborate for me, we synthesize ADH, and you can use the ADH to to send the formaldehyde, because sometimes we have a very ADH, so maybe the functional from ADH can send another formaldehyde. Okay, thank you.
Thank you very much, Prof.
Yeah.
Okay, thank you, Mrs. Krishna, for the questions. Is there any questions from the on-site participants? If there is no questions, maybe I will ask some questions to Professor Elias. As you explained before, the LDH can detect the organic compounds such as acetaminophen. Is there any possibility to set or to synthesize the LDH to become a drug delivery system? As we know that organic structure sometimes can be organic compounds, sometimes can be a drug, and I think it might be trapped between the layer or something like that, Professor.
So our group also use a drug. Yeah, we done already.
How strong the interactions between, I mean, the interactions or the strong of binding between the layer, each layer to the
strong binding.
strong
Yeah,
enough.
yeah.
So your research already
Yeah,
done
we
to
also integrate with the paraquat.
all right. For the next questions, if I'm not mistaken, you said that LDH is one of inorganic clay.
Yeah.
So it can be synthesized from the natural one. I mean the natural clay. No.
Yeah. You can use natural clay.
Like the research of Professor Mawardi from Tananapa, it can be synthesized from Tananapa as well. Okay. Is there any questions, everyone? Okay. Professor Ilyas, because there is no more questions. Thank you very much for your presentations. Now we are moving to deliver the certificate of appreciation, and it will be given by the chair of our committee, Bapak Alizar PhD. And also welcome our head of department. Once again, thank you very much, Professor Elias, for your amazing presentations. Now we are moving to the next keynote speakers, Associate Professor Anang. Professor Anang. Hello, Professor Anang Sedio Hutomo.
Oh, yes, hello.
All right, are you there? We are so sorry because we have a different time here
Yeah.
with our agenda. All right. Hello, Professor Anang Sedihotomo. Can you hear my voice clearly?
No, no, I can hear your voice.
All right. How can I call you, Sedihotomo Sensei?
Yes, Anang said.
All right. I will call you Anang Sensei. Okay, everyone. Before Anang Sensei present his presentations, I would like to read a brief biography of Anang Sensei. His full name is Anang Sedihotomo, and he was born in Bojonegoro, August 13, 1971. So you will have your birthday party closer, sir. And then he graduated his master degrees from Givu University in 1998. And then he continued his study in Givu University in 2006 until 2009. And then he also have many research and training history and honors and awards from Chief Citations Award from North Givu Police, Japan, President Certificate of Merit from Givu University, Japan, Hot Article Award, Analytical Science, Japan, Poster Awards in 10th Asian Conference on Analytical Science, Kuala Lumpur, Malaysia. And he also published many papers and he also one of the members of professional membership such as the Indonesian Student Associations, the Japan Society of Analytical Chemistry, and the Society of Chromatographic Sciences. All right. Anang Sensei will give a talk or a presentations about micro HPLC. Hello, Anang Sensei.
So,
Can you hear my voice clearly?
sorry, I have some problem in my connection now. So,
Oh, okay. We will wait for you.
can you hear my voice now?
Yeah, clear and crystal.
Okay. Okay.
Okay. Anang Sensei, your time for presentations will be 20 to 30 minutes if it's possible for you. Are you ready, Sensei?
Okay, I already.
Okay. Ladies and gentlemen, please welcome our next keynote speaker, Associate Professor Anang Sedihotomo. Time's yours, Sensei.
Okay, thank you for your for the opportunity to given participant in the fourth international conference on chemistry and science education. For confirmation, can you see my sharing slideshow right now?
Yeah, actually our committee give the slideshows, the
Ah,
screen. So you have no share the slide because you already handle it. Sensei.
yeah. Okay.
Uh-huh.
Yes. In this time, I will share my experience about micro high performance liquid chromatography and its applications. Yes, I am from Hamamatsu University School of Medicine, Japan. And so here, maybe you can see the logo of the 50 years an anniversary for my university. And then, so how about the next page? Can you see now?
Yes, sir.
Yes.
Yeah, because we have a technical committee here, sir.
Yeah. And so, for the next page, for the locations of Hamamatsu City is in the Shizuoka Prefecture, where it's located in center of Japan, and with the number of populations about 80,000 people. And so it's small city, but have tourist attractions, station and tea plantations and mandarin orange fields, car purification industrial area, as like Suzuki motor or Yamaha motor, Honda, yes. And for the next, this is a zoom of the map. I have lived in Hamamatsu for 13 years now, right now. However, I have also lived in Tokyo about 1 years in Hamamatsu, yes, Tokyo, and also Osaka for 6 months and Kifu for 9 years. This is a view of yes. This is a view of my university, Hamamatsu University School of Medicine. University have a hospital for the student practice. This is complex of the parts of hospital and the site of university. So combine of hospital and university. And my lab in medicine faculty department of chemistry. It is 5th floor. The second, you see the see the 8th floor. And so sorry. So this websites. There's only 2 faculties. Name Faculty of Medicine with 733 students and 267 nursing students. So the total is only 1,050 students. And there's number of employees. So board of the directors, 7, and professional and the nurse staff, the totally is 1,000.
Ladies and gentlemen, I think our keynote speaker have unstable connection, so maybe we will wait for a minute to take back to our keynote speakers.
Mi mah. Balalik ada dong. Balalik ada dong.
Okay, Professor.
Yes.
All right, you can continue the presentation.
Presentation. So in this website, so can you see that the number of employees is more than students. So when the next slide, so maybe I have the
Leonang Sensei.
yes. I'm sorry.
Right, never mind.
Okay. So this distance between Indonesia and Japan is about so 15,700 direct flights also, and so that Japan's maybe a very widely known from Indonesia about the Fuji Mountain, and Shinkansen, Sakura, Kyoto Temple, Sumo, Kimono, or high technology for robotics and automotive, like Toyota, Honda, Suzuki, Mitsubishi, Mazda, and so on. So this is my history, but so I will sort for the next time because time is limited. So I will discuss about the analytic chemistry. So maybe nearly with Professor Elias here before, but for discussions about the chromatography, I think. The analytic chemistry is a fundamental technology, but that supports many areas, such as life science, material science, environment science. So, what is analytical chemistry? So maybe knowledge to determine what and how much compound in a sample. For example, when we eat something, here is sushi. So the right hand, sushi is the famous Japanese food, and also nasi padang, maybe, or but famous for this padang Indonesian food. So when the taste of the food may be salty, so maybe too much salt. Salt is the sodium chloride, right? Sometimes we feel also food source, So maybe too much acid. This maybe too much lemon or other. Also, this extra hydrogen plus ion. So the analytical chemistry is widely applied in various fields of life, in industry, like to ensure high quality product by analyzing substance or steel, or for example, steel during a manufacturing process. Also for food, to provide safe food in market. And the medical field also early to detections of disease of by the blood test with quality, also the quality control of the product. So these are two important terms about analytical chemistry. Only two. The first is qualitative analysis. Yes, quality analysis is to determine what kind of compound in target sample. And also for the second is quantitative analysis to determine how much is a concentration like this for of the compound in the sample. In the analytical methods in analytical chemistry, we know that there are several methods such as gravimetric analysis. The amount of silver like this could be determined by white salt from the reaction, some reaction, and polymetric acid, also like titration methods, and also colorimetric analysis. This colorimetric is a device using the colorimetric that measure that the absorbance of the particular wavelength for lights of the specific solutions. So the bottom is instrument analysis. This so like such as chromatography and electrochemical determinations, NR, and so on. Okay, the chromatography is a physical methods of separations that is have a compound partitions about two phase, two phase only. One is a stationary phase that are don't move, and the other side is a mobile phase with the doesn't moving. And the solutions were spirited due to the term difference in how and they interact with their phase. Here is the illustrations of the red cycle as a sample, and the light blue as a model phase. So by the interactions with the stationary phase, the sample will come out with the flow of model phase. Then it's difference time when they come out. Chromatography is from two words. Chroma, the meaning is color, and graphians, meaning is record. So this is the first time when Russian botanists make a switch, especially observations of what the chlorophyll of the sun that circulation in the ether, and then they setting the column like this. Maybe can use can see the column, and they can split the yellow one and the green one. So the column will split by color. So then record. And the history of chromatography So since sweat aspiration with the pigment or chlorophyll of the leaf, so it become aspiration, yes, become technique become and continuously developing, yeah, like such as 1969 HPLC by Caroline and also 1975 ion chromatography by Small, and so fused silica capillary by 1979. So also until right now. So about the high performance liquid chromatography, I want to, yes, current developments, the high performance of chromatography technique is include development of new stationary phase, development of the high sensitivity detection methods, and downsizing of the capillary column. This will be saving resource simply than speedily analysis and support other built-on technology. And chromatography methods have been a lot of developed in order to overcome of a lot of analysis problem. The high performance liquid chromatography, HPLC, is liquid chromatography which commonly utilizes with palm to obtain the rapid analysis. Concerned with the environmental friendly analysis miniaturizations of the chromatography to be attractive of attention. So with the downsizing of the column, capillary liquid chromatography so rapidly developing, especially after inventions of the fused silica capillary in 1979. So, however, it's still important to maintain the performance of chromatography system, even they have downsizing. And the most excellent in modern techniques are to provide sensitivity and rapid sample of the chromatography system. The advance of many miniaturization of the chromatography system can be described of the sample low consumptions of solvents, reagents, packing material. Also for the second, allow to use high price reagents, either are stationary and mobile phase, and increase in mass sensitivity and so on. Also, so so can you see the battle? Yeah, but when the measurement one day takes 8 hours, it can be expected the consumption of solvent and waste to be 500 milliliter for conventional size, but for capillary size, just only 2 milliliter. For the next, this the instrument basically consists of the palm, injector, column, detector, and the data processor. So for this capillary liquid chromatography, the injector was using micro switching valve. The palm is a type of the syringe, a type attached to the micro palm. This kind of the separation column commonly used in high performance chromatography. So by the diameter, it can be divided into the conventional with the size of the diameter 4.6 millimeter, and capillary with size of diameter 0.32 millimeters. And so by the material, by the material column, it can be found that column made from stainless PET and polypropylene silica. Was this research to use this silica capillary column? The detail of classifications of the liquid chromatography based on column size or sample capacity and flow rates, it can code capillary liquid chromatography for the nano or micro liquid chromatography data. And it's this one that commonly used in SPLC about the detector. The classification of detectors can be divided into the two groups and measure, and their selective detector is for a limited species with the low background signal, so can get a good sensitivity. For example, conductivity detector, when the sample have ionic species. Also, the other is ultraviolet detector, UV detector. We call when the species have UV absorption. And also the other is fluorescent detector when the sample have fluorescent absorption. And the other hand, so universal detection is for unlimited species, but a very high background signal. So have a poor sensitivity. For example, universality is a refractive index detector. So there's more special that capillary column. The device consists of the micropalm and micro injector, capillary column, UV detector, and protein data. This is the time we succeeded in using the capillary column, which is 1 centimeter or centimeter in size. So it can imagine that what this size like a USB plug, right? So we use the suppressor. Yeah. Suppressor is the installed behind the separation column. Since the marble face is left have a high electrical conductivity sample with low electrical conductivity cannot be detected. However, the attaching suppressor there, because the electric conductivity is reduced and the sample with a low electrical conductivity can be detected like this. So suggested here capillary size for the parking suppressor column. Yeah. However, the actual situations of the suppressor is inconvenient because it need to be applied offline periodically. Like so, is for example, even the other backup suppressor. So I was able to shorten the time, but still cannot cross that weak point. So how to solve this problem? So as a quick look at the picture, the spedition column is followed by packing capillary suppressor attached with the 2 6-way macro switching column. The first use suppressor 1 to reduce the background and make a measurement, and the next the 3 centimeter long of suppressor for the field that time has during 3.5 hours. So can maintain to the background reduced by turning on the switch of suppressor to become the ineffective this time totally generated with one normal sulfuric acid solution. The regeneration will be complete in about 1 minute, and it will be washed in water. And also the after 3.5 hours, just before suppressor, the second suppressor effects wear off. The suppressor use basically use a strongly acid cation exchange resin as a packing material for anion analysis this time. So since it has ion exchange capacity of 1.8 milliequivalents. So when the mobile phase sodium bicarbonate fall, the cation in the suppressor was exchanged the background and the background in the reduced. This time the 3 centimeter long of the column has a flow rate of 4.2 microliter per minute. So can follow about the 3.5 hours. The background is the background found to be approximately 495 microsiemens per centimeter when reduced by suppressor from the high conductivity state. Measurement of the standard sample relative with modern ion. In suppressed ion chromatography reduce background, but allow sample to be detected and the positive peak. But then there is the basic of the indirect conductivity detections is the other methods. Yeah? The methods either to maintain background in high conductivity and the analyzed signal are detected as a negative peaks because the dilutions of the marble phase due to the analyte. This, for example, the detectors use the time is UV detectors. In which sample that have absorption can be detected directly as a positive peak, but for indirect detection with a negative peak. And for the determination of the anions using UV detector, so we can choose the white length about 210 millimeters, showing the optimum observation observance. And how about the stationary page? And in the column, the stationary page used is L column to ODS. ODS itself come from the word or octadecyl. Yeah? Octadecyl between 18 and silica 18 from and silica with the imaginations of on the silica gave alkyl, yeah? Alkyl C carbon 18 like this, for example, right in the like this, and the facts of number of the alkyl is unlimited to can be described like this.
Hello, Professor Anna. Ladies and gentlemen, I think Professor Anang have a bad connection. Please wait for some minutes.
Look like this spirit. Oh, sorry. Okay, maybe with the next slide. This is illustration when the element only natrium sulfate. So I will sort next. So when we use the stack, yeah. And so the other for the coating column, yeah, about the coating column, when using the polyethylamines to be octadecyl one phase in organic anion could be determined. And when using the imidazolium ion coated in the three with body silica in organic ions could be determined. So every for measurement, just this is for example for stock. So oxalates ion and bromide ion are sparingly when mix the sodium solvent in 35 millimolar. So this for test. So what is the optimum of this 15 milliliter, 15 milliliter from the sodium sulfate, and the Vocitec 20. This is our optimum size. And about the length of the column, when the column is just 1 centimeter length, also can be kept to the resolution and perspiration. And it is a standard result that can be obtained when using 1 centimeter column. So when we use an injector with the fixed volume of the 0.2 microliter with substitutions to the switching pulse by 6 parts micro with a loop of 0.2 microliter with the length, so 76 milliliter length, with diameter 59 nanometer. And so we can change the loop, can be extended to the large to get to obtain the large volume, so that a sample can be detected in the high detection limit. This is an example when the loop length is made 1.3 meter, so the Fourier concentration can be obtained 50 times. So the length loop can be replaced with the pre-column in effort to enrichment. So with the packing material, material with the height in concentration for the ion chromatography on ion exchange, so prevent high pressure and reduce the friction. And how about the packing material for the pre-column? Yes. So this is a sample of the enrichment column using the several packing material. I'm sorry, so I forget to change the Japanese font. So, and from the top is ODS, silica gel, non-exchange resin, so monoclinical also. Okay, and next, what about the focus of analytic problem is chromatography system is achieved through rapid analysis in high resolution specification of analysis of interest. Since 1969, HPLC to the rapid analysis was developed by using palm and utilized by small packing materials of the column. So in this time, by the operations in high pressure, HPLC afford to the shorten analysis time comparable by GC-mass, gas chromatography. So by the way, the recent years, the development of the ultra high performance liquid chromatography technique allow the rapid determinations of the protein as well as the applications of the fast ion chromatography to determine ionic sample by increase the plot number. So this high resolutions of the liquid chromatography can be obtained by minimizations of the particle size of the stationary phase when the affinity interactions, the pressure become higher, but can be countered by shortening the column. For the ion exchange interaction column by increasing the ion exchange capacity. The basic concepts of to achieve faster separation column is shorten the retention time by increasing the flow rates. However, it's in real because increasing pressure, reducing resolution, and use much of eluent running consumption. So the increasing pressure can be eliminated by using shortened column, even cause reducing the resolution. So reducing resolution eliminated by using smaller packing material of the column, even though it will be cause high pressure. Then eluent reduced by using a capillary column. By the way, ODS column is a very common use in liquid chromatography to spirit analyte and for ion chromatography to the use to anion analysis can be spread by coating the in ODS. The present methods describe the application for the fast ion chromatography using short ODS capillary column picked with the small particle size of the packet column to determine ion. This is a breakthrough of the DDAB, didoxyl dimethyl ammonium bromide, facilitated but to determine the approximate column capacity in coated flow rate 4.0 microliter per minute of the 10 millimolar DDAB. Breakthrough after approximately 14 minutes. So the corresponding maximum column capacity is 120 milli equivalent. And this is a comparison of the column lengths for the separations of the 7 anion, so that the 3 centimeters column was completely spirited and suitable for this method. So the effect of the packing material, the comparison of packing material size of the column, so that 2 micrometer particle size with greater than 5 micrometer. So the number of the theoretical plates for surface to be 2-fold. This affects of the concentrations of the mobile phase. Oh, next. How this change by pH elevation effects to retention become safe. From the graph, so that they maintain even pH around 6.5 until 7 is very important to obtain the better separation. And how about the effects of temperature? This is graph how the correlation between measurement temperature to the retention factor. Increase in the measurement temperature effect to be shorten retentions of the nitrates, bromides, and chloride. That they have opposite to the sulfate ion. However, it's easy control to temperature stability to avoid the mates of column to maintain the separations in better conditions where we have choose 50 whichever temperature. And so is a pay temperature. Yes. This is a chromatogram when flow rate was accelerated from 4 microliter per minute to 7 micrometer per minute. So even though it's look there was a decreased resolutions as for example, especially for the fluoride and carbonate P, but the separations of the 7 ion can be maintained with 2 minutes. And for the calibration under the conditions by measuring of the difference for the 5 different concentration of the standard sample like 0.1, 0.2, 0.5, and so on. So the calibration graph can be performed with the peak height, with linearity conventions about more than 0.98. And also for the detection limit, this is it's a convention from detail. The other hand, and signal to the noise set to more than 3-fold. It's a limit of detection. So the system has achieved to the low ppm level. For the repeatability, yes, and for the repeatability, the ratio RSD for the detection for retention time was below that 2% and the peak height with the below than 5% overall. And so the last that I have a lot of the methods. So finally we have what to the applications. This method was application like this to determine in organic ion in the tap and river water, all sample by directly injected and after filtering. And in this fast in chromatography methods using ODS capillary column to determine of the 7 inorganic anion can be achieved by DDAB, didoxyl methyl ammonium chloride by coating. And the elution order was fluorides, carbonates, phosphate, and chloride, bromide, so other. With the only 2 minutes, and this method was applied to determine inorganic anion in tap and river water sample. Also, the sample, so it is for suppression. For the we use the suppression method, so it is the real sample, water and the tap water, to measurement that was complete within 20 minutes, because so with the long column like 10 centimeter, and was found that the chloride ion is constantly larger, but because from the river water, river water. And the other the real sample, like this in Japanese, what umezake, yes. This called umezake. Umezake is like contain alcohol. The application of alcohol measurement used by indirect detection. Umezake, the real sample can be seen that umezake contain ethanol. Also for the application, to symmetrical sample have a healthy drink by water and also wasabi in Japan. So sectordextrins are additive agent to the tea. Tea is contain a catechin to remove the bitter compound. In addition, so wasabi is used a stabilizer so that the ingredient do not compose due to the air or to ultraviolet ray. If you look closely, that the word cyclodextrin is not written, but so this oligosaccharides, but sucker name with cyclodextrin. Also, this is the result. There's detections of cyclodextrin alpha using the L column ODS. So the order of the appearance is low, and so found that we measure the healthy milk. I found that so contain that gamma cyclodextrin also in the concentration what one to approximately reagent 0.25% calculate from the peak height. So it's 1 liter is about 2.5 gram gamma cyclodextrin. Healthy water did not show the clear picture, but it's so look closely, we can see a small gamma cyclodextrin like peak. This wasabi for sample. So wasabi is sample is originally pest, and so we need to pre-treatment. What's very difficult. I want to know that extract of confirmation for the extraction. So to dilute it with the 2 different concentrations. Separation was difficult of even the quantification. Finally, that the was passed to the filter 0.45 micrometer filter, but the pressure so what very high. So the filter closed quickly. That only 0.1 milliliter came out per hours. So it's very difficult to filter. And the other application is when the oligomer, polyoligomers, PEG 400, and also for science is a difference. So it's looked that this is going to be a bigger for the PEG 10,000, 1,000. And also the other real application is saliva measurement. So on the other hand, saliva, which is a typical biological sample, is absorbed to the ion exchange relation due to the electrostatics and hydrophobic interaction due to high metric protein, sugar, and amino acid, organic acid, lipid, and other, and etc. Other than increasing the ion exchange capacity that this results in decreased peak, safe, and delay in time. Only the protein can be removed by methods such as deproteinization, but other methods still remain and should be investigated. Regard this, I have done experience, but it's a very user substance. And the other sample is, when we are going to know about the different green leaf and yellow leaf, the flower ICChSE in Japanese is we call ICCchSE, and with the name, Greek name maybe the hydrangea microphilia, like this. And so for the pre-treatment, partly cutting the leaf and measure the weight and mass or crush and dilute, dissolve in water also, and by centrifugation, and also the final filter. This is for also like wasabi, but so difficult. And it can be seen that the green leaf contain a lot of nitrate ion. So so it's many real application for the example, like this, because important the control of environment and ecological balance. Like nitrogen oxide and NOx on nitrogen nitrogen, also called the nitric acid, also is called but even if oxidize that into the strongly acid, so there is a little effect that remains. And pollutions yearly rainfall in more acid rain, that rainwater become the stop when mixed with the alkyl salts as calcium, magnesium, magnesium. Maybe so I just about that. Thank you very much for attention about the in the micro liquid chromatography, so we can modify it by the injector and by the column, by the detection, also the other, and also the static phase, stationary phase, and also the in application of it. So thank you very much.
Okay, thank you very much, Anang Sensei, for your amazing presentations. Now we are moving to the Q&A sessions. Here, there is questions from the online participants, from Mr. Muhammad Amin from Khairul University. In the analysis of ions or compounds using the chromatography technique, support should be noticed the eluent or mobile phase and the stationary phase for analytical column. The question is how to decide the best or most suitable eluent, which is the types of eluent for analytical column to detect target ions or compounds in actual samples. Professor Anna. Should I repeat the questions? I think you have a bad connection, so I will read again the questions.
And the station face how to
Can you hear my voice, or you can read from the chat features in Zoom platform?
so to obtain the optimum of the mobile face, I think mobile face is so we have to verification with the different concentrations of the mobile face. So yes, maybe slot quite sorry. So the E1 or also the mobile face prepare with 5 or 6 kinds of the concentrations. For example, 0.1 or so 0.2, 0.4, the fourth, yeah. So that so can be until so how we can get the graph. The graph is the linear, yeah, linear depend on the concentrations of the alien, also the mobile phase. Like this. This for examples. The concentration, different concentration, yeah. Try to define the kind of the concentration. Then that confirm that we have the linear graph.
All right, thank you, Professor Anna, for the answer. And then, is there any questions for Professor Anna? All right, there is a questions from our keynote speakers, actually, Professor Anna. This is a question for Professor Ilyas.
Okay, for the question to Dr. Anand. One question. Our university have the IC brand Dynac, okay, and we use the normal column, okay, normal column. Can we use the micro column, or we must have the any part to use the that column, capillary column?
Yes, for the microcolumn, we have used the particle size 5, yes, in experience 5 micron, under. So, but in a dynamics column for the conventional size, normal size, everything for 30 size in micro. So if we have to if we want to make the capillary column, so we have find the particle size is below than 5 micrometer.
Yes, thank you, Professor Anna. Is that clear, Professor Elias, for any further questions? Okay. Is there any questions from the on-site participants or the online participants? If there is no questions, maybe I will ask a questions for you, Anang Sensei. can we use the micro HPLC for enantiomer separations? I mean for the chiral organic compounds. Can we use the micro HPLC? Maybe by using any specific or a chiral organic compound for stationary phase. Is it possible to use the micro HPLC to do enantiomer separations?
Oh yes, exactly. With in thermal application, so we can use micro liquid chromatography for the internal analysis, because so the very high, so you can modify modification with the coating material also to have to approximately to analyze the sample, I think. Also, of course.
All right, thank you very much, Professor Anna. I think this is the end of the presentations of Anna Sensei, but before you leave the Zoom platform, please, we will deliver our the certificate of the appreciations for you. And you will always welcome to Padang as your slide. You can eat nasi Padang when you come directly to Padang, Ana Sensei. Salam dari Pak Budi, kata Pak Budi.
Okay, let's come at that.
Actually, Bojonegoro to Padang is not a quiet far, and you will always welcome to Padang. Thank you very much once again, Ana Sensei. Right, ladies and gentlemen, I think this is the end of our keynote sessions. We will continue to the next sessions after the break, and I will give this agenda to our MC, Miss Yunita. I'm so sorry for any mistake. I thank you for having me to be a moderator today. I will end this keynote sessions with Assalamualaikum warahmatullahi wabarakatuh. Good afternoon and have a nice day. Thank you very much.
Ladies and gentlemen, the session is over. The next keynote session will be continue at 2 p.m. Thank you for your attention. English is not Ladies and gentlemen, back to me, Master of Ceremony. Before continue to the keynote session, we would like to introduce our third moderator today, Mrs. Guspatni, Master of Art. She received her master degree from University of Nebraska-Lincoln, USA in 2014. Ladies and gentlemen, please welcome Mrs. Guspatni.
Yes. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everybody. Good afternoon. Are we good to start? All right. The Honorable Head of Department of Chemistry, Dr. Budi Octavia, MSI, the head of the committee, Mr. Alizar, PhD, the keynote speakers in this conference, senior lecturers, the organizing committee, and all of the audience attending this conference. It is such an honor for me to be the moderator of the second session in this fourth international conference on chemistry and science education. I am Guspatni. For the next 3 times 45 minutes, we'll moderate all the audience to attend
to the speech in the field of chemistry and science education given by our keynote speakers, Professor Dr. Anna Permanasari, MSI, Professor Dr. Mawadi, MSI, and Professor Nur Hasniza Ibrahim, MSI, in the consecutive order. Our session will be done in the following order. About 30 minutes presentation from the keynote speaker, followed by 15 minutes question and answer for the session. I will choose 1 or 2 questions from the audience. Online audience can post their question onto the chat box in our Zoom meeting, while participants in this room can raise hand and say their question directly after appointed by me. And at the end of each session, the handover of the placard and the certificate from the committee to the keynote speaker will be done. All right. To save time, we will begin the first session with the first keynote speaker. Please welcome Professor Dr. Anna Permanasari, MSI.
Thank you very much, Miss or Mrs. Miss, Mrs. Padi. Is it right? Yeah. Okay. Thank you. Thank you for the opportunity. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Is it okay if I'm still in the chair? Standing, yeah? Yeah. So the operator. Yeah, the operator will help me to share the slide. Which one? The slide, please. Okay, on this session, actually, I only want to share our experience in mainly in educational research, yeah, because actually I'm not from chemistry or science education background. So my experience in educational research is only by, what is it? By, only by experience, not by formally education. Yeah. Okay. So my research in education was started on 2007. Yeah. Yeah. I started from the scientific literacy. Yeah. After that, our research moved to the science education. Yeah. And then now in 6 years, recently, we try to make a kind of new research in low carbon education. So this low carbon education terms is rather new, yeah, in education, mainly because we have done the searching, yeah, we have done the bibliometric research on low carbon education. So it's a very very few articles that has been published around the low carbon education. So this low carbon education research is, I think, it's still interesting to us. Yeah, because yeah, this is the new trend on science education research. Yeah. Okay, we can start from this. Next slide, please. From this. Yeah. So this is a view a few articles that has published in some publisher, yeah, in reputable proceedings, in accreditation journal, and in reputable journal. So these 5 articles, if you are now Googling now, yeah, and you choose the keywords low carbon education, so the 5 articles, top 5 articles that will rise up in your searching is this articles. Yeah. What is it means? This is means that the article about low carbon education is still a view. Yeah. So this is a challenge to us, yeah, to make a kind of broader low carbon educational research. Yeah. This research has been done, yeah, by our student, by our team, yeah, our student from postgraduates, yeah, from science education, from degree, from master and doctorate degree. Yeah. Okay. So in this session, I will introduce you to what is low carbon education. Yeah. Next slide. Yeah. Talking about low carbon education, I think this is the terms that you can you can seek in the Google. Yeah. Low carbon education is very close related to the low carbon behavior, low carbon fuels, low carbon technology, low carbon eat style, and low carbon diet. Yeah. So these terms is always followed, is always what is it in text, yeah, in the low carbon educational research. Yeah. Okay. So let's we come to the what is the meaning of low carbon? Yeah. Low carbon means causing or resulting in only a relative amount, relative small net release of carbon dioxide, yeah, into the atmosphere. This is described by Oxford Dictionary. Cambridge Dictionary said rather similar with, yeah, low carbon means low carbon buildings, yeah, related to activity, business, etc. is one that causes only small amounts of carbon dioxide to be added to the atmosphere. Yeah. So by these two definitions, we can say that low carbon related to all life processes that seek to produce as little carbon dioxide gas as possible. Yeah. So low carbon is very close related to the CO2 release. Yeah. Carbon dioxide side release. Yeah. So this is what is the meaning of low carbon. Next slide, please. So what is low carbon behavior? Low carbon behavior is related to the low carbon lifestyle. Yeah. If you wasting food, yeah, if you take food too much, but you eat this food, yeah, and give it a rest, yeah. So you are living in the high carbon behavior. Yeah. If you use the excessive water in all of your daily life, so it said that you are not in low carbon behavior. Yeah. If you are watched by TV, you are watched by, or is it laptop while sleeping, and it's can be done sometimes, yeah, frequently. So you are living in the high low carbon. If you prefer goes to school by your own car rather than going by bus or going by bicycle, yeah, that's not related to low carbon behavior. So this low carbon behavior related to how we are living with the minimized using carbon dioxide. Yeah. So that's the meaning of low carbon behavior. Next. Yeah. Talking about carbon dioxide, I think you all know that carbon dioxide comes from various resources. Yeah. It will come from the woods. Yeah. It will come from the fuels. Yeah. It will come from the coals. Everything will come from the renewable energy. Yeah. Will goes to CO2 excesses. Yeah. That's the CO2 come from. Yeah. And then I have some, what is it? Some reference, yeah, from the, wait for a minute, yeah. BBC report, yeah, from the BBC report from the next slide. Yeah, from BBC reports, yeah, it is reported on 2009. So this is for 14 years ago. Yeah, 14 years ago, some expertise, yeah, some expert from science, yeah, from science and technology, yeah, predict the amount of CO2 release in atmosphere by the world. Yeah, if we see the graphs here, please graph. Yeah, if we see the graph here, yeah, we have a we have a trend. Yeah, we have a trend of CO2 increasing. Yeah, from 1990 to 2030. Yeah, so it is can be read. Yeah, can be seen by that the trend was flat. Yeah, from 1990 to 1000, year 2000. It was the flat curve. But after that, it was sharply increased. Yeah, it was sharply increased. And the prediction is in our year now, 2023, yeah, it predict more than 60 gigaton. The CO2 gas are released in the to the atmosphere. So this is a kind of horrible things, yeah, because it can be stopped starting from now. Actually, yeah, we can stop the releasing of CO2 gas actually from now. It will wreak havoc on the world. Yeah, can you imagine it? What and how the life of our children and grandchildren will be in, for example, 2050. Yeah, so this is a very something that should be our concerns from now. Yeah. Okay. So because of this reason, the United Nations create one world goals. Yeah, we called it Sustainable Development Goals. Yeah, Sustainable Development Goals, which has elaborated 17 goals, namely within the framework of Sustainable Development Goals. Yeah. Okay. These 17 sustainable, please, next slide. Miss. Next. Yeah. Yeah. Okay. So I think these 17 global goals should be achieved, yeah, by all of parties in our community in the world, yeah. But our concerns in mainly education, yeah, is only two, yeah, two goals. Two goals. These are education, number 4, and climate action, number 13. Yeah, the number 13 and the number 4 is our concern related to low carbon education. Yeah. Okay, so I think the industrial and technology society moves by carrying out the key issues. One of them put forward, yeah, a concept of a concept from the European Parliament Research Service. Yeah, jadi European Parliament Research Service proposed some concept of these issues. Yeah, the name is LCTs. Yeah, low carbon technological and science in industrial issues. This is proposed by Parliament of European. Yeah, next please. Yeah, 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 yeah. So this is the key issues for opposition in LCTS, industries issues. Yeah, this is proposed by European Parliamentary Research Service. Yeah, on 2019. Yeah, we have 3 aspects, 3 points of this low carbon technology that has to be developed. Yeah, the first one is about renewable energy. The second one is low emission transports. And the third one is carbon capture, utilization, and storage. Yeah. Each of renewable energy, yeah, such as wind, tidal wave, ocean, solar PV, hydropower, geothermal, and others, yeah, have the some reason, yeah, why they choose this renewable energy as issues. Yeah, they have some reason. For example, sound and visual impact. This level from turbine, issues of trust with institution involved, distribution of benefit. Yeah, and then lack of farmer consultation, issues of trust with developer, and etc. etc. In low emission transports, we have some issues liquid via biofuels and electric vehicles. Yeah. So the reason, the key reason for opposition is impact on land use, change for community in the global south, inconvenience in finding charging station. For example, extra distance needed to travel, extra battery cost. Yeah, and the last aspect, the last point of low carbon technology is about carbon capture, utilization, and storage. Yeah, concern of what type of power plant extraction. So this is the proposal proposed by European Parliament Research Service. Yeah, so this is state that the what is it the how to overcome the problems in our society. Yeah, is very closely related to the this climate action. Yeah. Okay. Next slide, please. Okay. Next. Yeah. Okay. So, what is low carbon education for? Yeah. Why we have to research? Yeah. Why we have to make sure that our student, our new generation, should know about this low carbon literacy. Yeah. Low carbon education is only for carbon literacy. So carbon literacy aims to establish a common baseline understanding of the relevance and impact of carbon dioxide cost and our carbon footprints with a special focus on enacting high impact climate solution. So this is will goes to no one should be excluded from a global movement, pursuing meaningful and action-based climate education for all. So this is the importance of low carbon education for our next generation. So how can we do? Yeah, by this challenge. Yeah. So what we have to do is, yeah, our low carbon get our low carbon education target is the first one is low carbon literacy. What is the meaning of low carbon literacy? I think we have already known. But low carbon literacy is actually similar with the other terms, yeah, environmental literacy and sustainability literacy. So all of these terms, yeah, will go through, yeah, if we do this, if we make sure that our student, our next generation now understand about low literacy, it will go through low carbon society behavior. So of course, low carbon society behavior, if it is, yeah, in reality, yeah, so education for sustainable development and climate action is the two contexts in SDGs that can, yeah, in this low carbon society. So if we have done this, so sustainable world will come. Yeah, so this sustainable world will come. Okay. So yeah, we are in academic atmosphere. We are all in what is it? Higher education. So what should we do with this fact, with this problem? Yeah, we can do some kind of research, and this is what we are doing now. Yeah, doing in low carbon education research. Yeah, how to make a research on low carbon education. We can do this step by step. Yeah, we can do with the very easy stage. Yeah, we can do the first stage of this research, preliminary research on low carbon behavior. After that, we can move to the next stage of our research, innovation, development, yeah. And then after that, yeah, we can do the dissemination and others. Yeah, so this is step by step research in low carbon education. So where we are doing now, yeah, we have to do the all of these stage. Yeah, along the 7 years we have to do this. Yeah. Our research in education need context. Yeah, I think you all agree with. Yeah, we need context to do the research in education. So related to this low carbon education research, we have some context. Yeah, this is some context that we propose. Yeah, that we suggest. The first one is about renewable energy and greater energy efficiency as the key enablers for decarbonization. Yeah. The second context, we propose alternative energy, gaining energy from decomposition, using local wisdom to change. Yeah. And then the next context, changing waste or garbage into the valuable things. And the last one is reducing energy demand in production to decrease energy demand in general. So this is some, yeah, a few of contexts that can be used in your research in LCE. Yeah. So by this context, we can automatically increasing the share of green energy significantly. Yeah. Increasing energy efficiency is a catalyst in gaining more cost control at the local level, making production more resilient in context of price shocks and security of supply. Yeah. Okay. Next slide. Yeah. So this is some research title also in our LCE, yeah, how student and society pertain low carbon behavior. Yeah, we can research this from student from elementary, from preschool, secondary, what is it, higher level and higher level, even in higher education. Yeah, and the next one is developing material teaching such as module, learning model, multimedia, lab work activity. Yeah, the last, enhancing student to swing on energy efficiency. Yeah, and then, yeah, because my research is in STEM, ESD, so we combine this STEM ESD into the low carbon education. So this is what we have done, yeah, using the collaboration scheme, yeah, with the university in Japan, yeah. For example, this is our recent research, yeah. We have done the research, the 3 years research, yeah, done by collaboration with ICChSE University, yeah, you know, but you know, ICCchSE University, ICCchSE is a city, yeah, in Japan who very, which very care, which very concerned on the these SDGs, on the this education for sustainable development, as well as in the low carbon education. So we make a kind of collaboration, yeah, with the research title, The Development of Low Carbon Environmental Education Learning Model for Lower Level, yeah, for elementary schools, yeah, in West Java, Indonesia, and ICCchSE Japan perspective. Yeah, this is done with 3 years periods. In the first year, we conduct the research on important elements supporting the low carbon environmental education models in ICCchSE. So we are going to ICCchSE, we learn, yeah, anything, everything from ICCchSE. How ICCchSE arrange the education for this low carbon. Yeah, it's very, very valuable going to ICCchSE. So I think you have to come to ICCchSE because ICCchSE is one of the green city in most green city in Japan. Yeah. After that, yeah, we investigate the condition of carbon footprint in our school. Yeah, in Indonesia perspective. Yeah, we use the instrument, yeah, that we have arranged in collaboration with ICCchSE team. Yeah, we make a kind of research, yeah, a little research in about the low carbon behavior in elementary school, and after that we know the problems ways of our school. So we made a kind of model, yeah, model of environmental education. We develop, we analyze, and we evaluate these models, yeah, through the 1 year studies, yeah, about this low carbon in Bandung, in Sukabumi, as well as in Bogor, yeah. So this is our research in low carbon in the first year, in the first research, yeah. Next research, we move to the development of science learning material low carbons, yeah. This is a kind of dissertation research, yeah, supervised by me, Professor Agustia Budi, and Professor Ida Hamida. Agustia Budi is from chemistry education. Ida Hamida is from physics education, because we are now doing in science education, yeah. This low carbon education to enhance environmental literacy of science perspective teachers. By this research, we have some outcomes, yeah. 2 article international conference with IOP proceeding, 2 article in accreditation journal, 1 article in reputable journal, and 1 book of LCA granted. We have 1 book granted, yeah. If you interest in this book, yeah, you can ask me, I will share to you. Oh, yeah. And the next research in LCA also involve my doctorate program, the development of low carbon media integrated to universal design for learning, UDL, yeah, for inclusive school, yeah. This is our last research, yeah. doing by Muhammad Nur Huda. This is he has from dissertation postgraduate research, yeah, and doing by me, Professor Ida Hamida, and Professor Ade Gafar, yeah. So the outcome of the research is one learning module. Yeah, we have two modules, yeah, and three articles in reputable journals, two articles in international conference with reputable proceeding, two grant Haki, yeah, as the ebook and the software of this design for learning UDL for inclusive school. And the last one, yeah, the research is also for our master student, yeah. This is our master student. Our master student can build, can develop the website. This website name HTTPS, yeah, blah blah blah, Ipa Budila website. You can come to this website and you can learn some more. What is it about low carbon? Yeah, and this is a thesis research, yeah, environmental for 8th grader after the learning through website for sustainable development framework. Yeah, the outcome, I think some journals, some article in journals and in conference, one book chapter and one web chapter. This is the what is it? The outcome of our student projects on low carbon education. Yeah, perhaps you are all in mainly in Universitas Negeri Padang can do the same research. We can collaborate. Yeah, we can collaborate to make this low carbon education. So many firms that can be arranged, that can be developed along the for the research on low carbon education. Yeah. Okay, I think that's good enough. Yeah. As I told you, yeah, I just share our research to you. So if you are interested in this research, you can join us to do the research. Yeah, you can come to Universitas Pendidikan Indonesia to do the research in PhD program, for example. Yeah, we do this until now. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Professor Anna. For development. Yes. Okay. Okay. Although you said that you didn't get undergraduate, postgraduate, and postgraduate in education, but actually, for your report in the that you have about 240 articles published in international and yeah, exactly right. Yeah, actually, as I stated in previous, yeah, I'm from analytical chemistry. Yeah, S2 from analytical chemistry, ITB, S3 analytical chemistry as well. Yeah, but I'm doing the research in education because I think this is my passion. Yeah, I'm doing the research on chemistry, and it was stopped on 2013. After that, I'm going to do the education research because education research is very interesting to me. Yeah, maybe I apa ya namanya? Saya ditakdirkan my destiny. Yeah, my destiny is in chemistry education, in science education. So I love to research in science education. Now I'm doing the research in education. Okay, yeah. Even though, yeah, my home base is pharmacy. Yeah, my home base is pharmacy. Yeah, I'm doing the what is it? A little research about analytical chemistry in pharmacy. What is it? Extraction using the what is it? LCMS, blah 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 blah. Yeah, but it is not enough to make a kind of mutual article. So I didn't make an article in our field in analytical chemistry. Yeah. Previously, Professor Anna did research on learning approach
literacy and STEM. And it is very interesting now that you turn into this specific field of education.
Yeah.
It's about low carbon education, that something that is very related to our response, our being as a society
Mhm.
that is responsible to protect our environment.
Yes, yeah. That's why in the next, in the second research, I'm going to STEM research. But and then we realize that STEM research is nothing if we do not do our we do not make sure that our environment is green. So we come to the STEM ESD, Education for Sustainable Development, and more focus on low carbon now. Yeah, STEM, ESD, low carbon. That's the three. What is it? Three keywords. Yeah, three keywords that I have done and I'm doing now as well.
This is also in line with the demand of our new curriculum Merdeka, as stated in this in the learning goal to achieve sustainable development goals.
Yes.
Right.
Yes.
So, as you know, audience, this is very interesting topics. If you have question, you can raise hand for participant attending this seminar line. Or do we have question from online audience? Because let's see. You have question? Please say your name and say your question directly. You need microphone.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good afternoon, ladies and gentlemen, especially for Ibu Ana. My name is Irfan Ananda Ismail, and I'm magister student, chemistry education. Same with you. And here is my professor, Dr. Mawati, as my supervisor. So I have been listening entire your presentation. It's such a great topic, I think, because we understand there is climate change in our world, especially global problem. This is climate change about the carbon footprint. And I also see your website, your learning interactive. And so I have some question for this topic. But maybe all of you understanding we have implementing the Merdeka curriculum. And in Merdeka curriculum, we have some topic that we will teach to our students. But if I saw your learning, it talking about green chemistry, it seems, correct me if I'm wrong, but how this will be correlating with Merdeka curriculum? Because in my humble opinion, I cannot see green chemistry in Merdeka curriculum. Or maybe you have something that I didn't know. So this, your great invention can be implementing to our student in the future. Because this is such a great topic. I love to reduce the footprint. I love to use transportation mass than my private car. So I hope this your invention can be implemented and regulated with the Merdeka curriculum. Thank you, ma'am. That's all from me. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, this is about curriculum Merdeka Belajar. Yeah, yeah. Okay, I agree with you that in curriculum Merdeka Belajar, yeah, we have it should be some issues related to low carbon. It should be, yeah. But I think in the level kelas berapa ya? Kelas 1 SMA itu, ya. In 10, 8, yeah. 8 and 10, yeah. In 10th grade, yeah, curriculum, yeah, I think it's kind of the integrated science, yeah. Integrated science. We have a curriculum in integrated science, and it is include the green chemistry as well. Yeah, green chemistry is not only find something find some what is it find some chemicals that come from the non-renewable energy as well. But if you use chemicals as a view as possible, that's a low carbon behavior. Yeah, if you use for example, you use the low cost of chemicals in our laboratory practices. Yeah, so we are going to the low carbon behavior. If we think about the reactor, the reactor, we use the energy, the resource energy, not from the what is it? Not from the non-renewable energy. That's a kind of high low carbon behavior. Yeah, that's all of something that we can relate it to the low carbon behavior. Yeah, that's what we think about some research in chemistry education, but this is in progress. Yeah, ongoing. Yeah, it's about how to make a kind of biotechnology. Yeah, biotechnology in biochemistry. Yeah, we use some enzyme from natural. Yeah, that's a kind of low carbon behavior as well. Yeah, there's so many aspects in our chemistry. Yeah, that can be used as a term in our research in chemistry education. Yeah, based on low carbon framework. Yeah, okay. Do you know what I mean?
Yes, I get it, bro. So it's not rated on the Merdeka curriculum as well, but there is some part we can connect it
Yes.
to this low
Yes.
carbon behavior.
Yeah.
Like that.
Yeah.
It's
I
not
think
rated.
if we have to publish our modules for what is it 11 and 12 grade, yeah, it should be there. Yeah, the low carbon on chemistry it should be there. Ya, tapi belum terbit. Ya, itu belum terbit, belum ada. Yeah, so we only use only a view of our low carbon chemistry in what is it 11 grade. No, in 10 grade. Yeah.
Okay, thank you, bro. Great explanation.
I think this is a chance for you all, yeah, for you all of our chemistry educators, yeah, to think about what should be done, what should be think, what should be created on these firms in our teaching and learning process, chemistry, yeah. It is a kind of good chance to you all. Because it is still a still a few articles, yeah, published in related to the chemical education in perspective of low carbon. Yeah, it's a very huge, yeah, to research, to make a research to you all.
Questions about we as educational researcher, or maybe the audience as the prospective teachers.
Yes.
And also they will do extra research in their later on. Maybe when they continue their study in the master's degree, they will also do research at school. What should they do to implement low carbon education principle
Yeah.
in the context of classroom learning?
Okay. So the first you have to think is which is the topics that closely related to the low carbon. Because not all of our topic in chemistry, yeah, is relevant to the low carbon. Yeah, So we have to find out what is the topics of this low carbon. After that, we'll think about how can we do the learning process. Yeah, how can we arrange? For example, we can do some experiments. Yeah, some experiments in chemistry with a low carbon framework. Yeah, we can do this. Yeah, but yeah, actually you have to find out some articles before. Yeah, some articles related before. Yeah, because I believe you can all do this because this is very easy topics, very easy experiments, very easy media to build, to develop. Yeah, this is very easy. Even though this can be done by our what is it? S1 S1 degree. Yeah, undergraduate students. Yeah, this can be.
I'm actually personally interested in this topic because I think of my responsibility as a lecturer, as an educator, and as a researcher in protecting our environment by first reducing the emission of carbon dioxide,
Yeah.
like the first principle that you said previously. So if the audience, any of you is interested with this topic, we can contact you, right?
Yes, please, with pleasure.
All right. Ibu Ana,
Yeah.
thank you very much for this motivating speech about low carbon education. I hope we can get all the benefits of attending this conference.
Yes,
Thank
of
you
course,
very
we hope
much.
so.
We can give a round of applause to Ibu Ana. Okay. All right.
Thank you very much.
You're welcome.
Assalamualaikum.
Waalaikumsalam. Before we end this session, the next activity is the handover of the placard and the certificate to Ibu Ana, and this will be done by Ibu Trisna Kumalasari. Please come to the front stage. Dear participant, there is a change in the order of the keynote speaker. The next speaker will be Ibu Associate Professor Dr. Noor Niza Ibrahim. How can I connect to her?
Assalamualaikum. Apa khabar?
Good afternoon.
Good afternoon.
Dr. Noor Niza Ibrahim.
Yeah.
What should I call you?
You can call me Dr. Niza also, can?
I'm sorry, I can't hear.
Dr. Niza. You can call me Dr. Niza.
Dr. Niza. Okay, nice to meet you.
Nice to meet you.
I'm Guspatni, the moderator of your session. Okay, before we begin your session, I will read your profile. Correct me if I am mistaken. Okay. Dr. Nur Hasniza Ibrahim is a lecturer and a researcher at University Technology Malaysia. She took her undergraduate degree on medical science at University Putra Malaysia, and then pursued her master and doctoral degree at University Technology Malaysia. She has many awards on educational area, namely Excellent Awards, e-learning awards, and research awards. Tons of awards. It's amazing. And she has many professional experience in the level of faculty, university, national, and international. It's an outstanding achievement. Her expertise are on chemistry education, science education, and teaching and learning, and especially in STEM education. Today she's going to give a talk about STEM education and its relationship with innovation. Okay, Professor Dr. Niza, are you ready with your presentation?
Yes, I will share my presentation by myself.
We cannot see your share screen yet.
Yes, I'm not sharing, but so I will share by myself, okay?
All right.
Okay, wait. I will share, wait. Can you see my slide?
Yes, we can.
Okay. All right. Sorry, here is Azan. Okay, I will begin. Oh,
Time is yours.
okay, thank you. But do you hear anything from here? Not?
Yes, we can see your screen.
Okay. Bismillahirrahmanirrahim. Assalamualaikum and good afternoon to honorable keynotes here and the organizer and also the audience of the International Conference on Chemistry and Science Education 2023. First of all, I would like to thank Universitas Negeri Padang, Dr. Budi especially for inviting me today to share my work or my presentation in this conference. Okay, today I will be sharing my work entitled, which is fostering innovation through STEM education. So this is a little bit overview of my presentation. So I will share with you the importance of innovation, how STEM education can foster innovation, and a little bit analysis on innovation in STEM education. And also the last one is the practice of innovation in STEM, which is in UTM. Okay, we begin with what is actually the innovation. Okay, according to Jamie Notter, innovation is actually change that unlock the new value. Okay, what innovation is change that unlock the new value. Okay, according to Thomas Edison, we all know who is the Thomas Edison. There is a way to do it better. Find it. He is, as we know, he is an inventor. Edison made already 999 unsuccessful attempts at inventing the light bulb, right? But he said that I have not failed, but I have just found 999 ways that won't work. Okay. He also said that genius is 1% inspiration and 99 is perspiration. So to invent something, you need a good imagination and a part of junk. So this is Thomas A. Edison. He's a great inventor. Okay. And this is Albert Einstein that we all know who is Albert Einstein, who found the E equal to MC times 2. Okay, he said that you can solve a problem on the same level that it was created. You have to rise above it to the next level. This is from the Albert Einstein. Okay, we can see also this is inventor from Muslim. We know that Ibn Firnas, he invented the first human to fly, and we know that although he invent something that this is the first one, right? The first person that invent how to fly before right and right, which is the aeroplane. This is Ibn Firnas, but actually he invent how human to fly, but and then not really successful. He don't know maybe uh, maybe to run or maybe to land it lah safely. Okay, and then we also have this inventor from Muslim juga, Muslim, which is Ibn Haytham. We all know that the camera we use now is actually from Ibn al-Haytham. So he is the first one invent the camera, obscura camera. So this is the Muslim scientist. Okay? And then why actually this is all the innovation in bullet train that can travel very fast. Okay, this is bullet train, and also maybe the simple example of innovation, which is using the watermelon. So we can have, this is some of the example of innovation. And then we know why actually the importance of innovation. Innovation is actually a field of economic growth, and also innovation can improve our quality of life. And we know that innovation can solve specific problems, and it can shape our life. And some of our product or some of our research can, if you still innovate it, it makes stay relevant to the community or to the others. And why actually innovation? Innovation means that the definition is introducing something new. And without innovation, there is nothing new. Without anything new, there will be no progress. If an organization isn't making any progress, it simply cannot stay relevant in the competitive market. So innovation has a significant way to combat critical social risks and threats. So innovation is very important in our society. So this is some of the fundamental outcome of innovation. So communication, education accessibility, innovation can help reduce sickness, poverty, and hungers. Innovation also can help our future jobs, can make the economic growth, environmental sustainability, such as low carbon society just now from Prof. Anna, and also our well-being. So how STEM education can foster innovation? You can see here what actually in STEM innovation through STEM education, what actually the STEM education can give to us in innovation. So some of it, if we implement the STEM education, we can inspiring creativity and curiosity. We can enhancing collaboration and teamwork. We can cultivating a growth of mindset. We can linking a STEM education and with the real world application, nurturing a culture of experimentation, fostering an innovation mindset. Okay, we can look one by one. You can see here. I'm not sure if you can hear from here. There is azan, but it's okay. If not here, okay. So the first one is encouraging creativity and curiosity. Okay. For example, we try to give for the student. We try to give situation in the class. For example, we ask them to do maybe a project. For example, a cleaner robot, in the river. Okay, that can have the take the dirty in the river, or maybe how to develop a hot air balloon, or maybe how to develop a water rocket. All of these activity actually can create an environment in which the student are encouraged to explore the experiment and come up with a new idea how to solve that problem. And with this project or this activity, the students are encouraged to ask questions, to take risks, and come up with the innovative solution through open-ended project and activities, such as example that I given just now. So to enhance their creativity, with doing this, they will make creative works. They can have their imagination. Students are given opportunity to express themselves. This is using the STEM education. Okay, second one is promoting collaboration and teamwork. For example, we give the student a project, for example, to build maybe a bridge from the straw. Okay, we can see this is the make them collaborate to each other. The student actually brings their unique strengths and ideas to the table, and then they will learn to communicate effectively with others, and they will have provide opportunity for them to work in teams, and actually this mirroring the real world scenario in future if they works in the future in STEM field. The second is when doing the STEM education, we can cultivate the growth of mindset. When the student encounter a problem, maybe they encounter a problem when doing the project or anything, activity, experiment or anything. This is, for example, to stable the straw tower. Maybe they will not give up. Okay, this is maybe they need to they know they need to solve that problem. They need to solve that problem. They need to seek help. They need maybe try another way to solve that problem. Try to overcome that problem. So this is we call cultivating a growth mindset, which is the student will persist in the face of setback and believe the power of learning and effort of learning. So the student will encourage to learn from failure, to adapt their approach and keep trying. And this is an attitude that embrace the challenges. And then we'll go I think this is the best linking the best things that if we implement STEM education, where we linking the STEM education and real world application. One of the marvelous, I think this is a marvelous aspect of STEM education, it is ability to connect this classroom learning to the real world, actually the real problem. The student will become excited and eager to explore and find solution. Okay, we can see here if we do this STEM education that to the real world application, this is showing student how the knowledge and skill they acquire then can be used to solve the meaningful challenge. When the students see the relevance, what they already learned, they make their motivation source. They are very eager to learn more. And it actually bridge the gap between what they already learned and the practical application. This is, I think, the best thing in STEM education. And then it's also exploring new ideas and nurturing a culture of experimentation, where the student actually we in STEM education we actually provide a safe space where students can explore and can do research, can test hypotheses, and they can learn through hands-on experience and then reflects back what they already learned. This is all to encourage the student in retest the situation, and this will nurture their curiosity, their creativity, and try to solve the problem. And then we have this one, which is fostering an innovation mindset. If we in STEM education, actually failure is a stepping stone to success. For example, Thomas Edison, before this we already mentioned, experiment and we invent the about 999 times. And then at 1,000, then they success. So it's actually we need to take steps to success. Fail your ways to success. So we actually in STEM education, we emphasize the importance of failure as a learning opportunity. And the students are encouraged to take risks and try new things. Okay, and then this is maybe this is some of the overview how the STEM education is help in innovation, and innovation is very important in our life. And then we also do something analysis exploring the innovation in STEM education using the maybe a little bit systemic literature review. Okay, in this literature review, we identify what is actually the benefit of innovation in STEM education, and also we try to explore what are the innovation that they invent in the teaching and learning process. Okay, we do this is the database that we try to look out, which is Scopus, Web of Science, and also ERIC. We try using innovation and STEM and education and school. In the same way, we do it for the Web of Science and also for the ERIC. And then we try to make it limit it to English and limit it to 2019 until 2023, and then we limit it to journal only, and then we limit the publication. It's full publication lah, not in press. And then this is we call it, we doing the systematic literature review. This is the diagram we call Prisma. If you can see what we have 4 steps in this part, which is identification, screening, eligibility, and also inclusive. So in identification, so we are searching in Scopus. We found out using the term of innovation in STEM education in school. So we have found out about 462 papers. And then while in Web of Science, we searched it, we found out about so many, because 1,209. And about ERIC, we found out about 181. And then we screened these all papers, and then we found out Scopus, which is related to us, and 22, and which is 22 papers. While Web of Science, before this we see with a lot of in Web of Science, 1,209, but in page 1, page 2, page 3, we search it, which is only about 1 until page 4, maybe page 4, which is we already found out is about 35 papers that regarding to STEM education, and others maybe is about the term cell, which is pure science, not the STEM education. Okay, and then we found for ERIC about 7, so total is 64. And then we try to follow the criterion, remove non-science, non-English, book chapter, conference, and then we eliminate the duplicate record, remove, and then we do for eligibility, and then we found out for about 20. Then lastly, after we already inclusive it, so it's about all the papers that related to our research is about 17. Okay, this is for the objective 1. We found out that what are the benefits of innovation in STEM education. We found out 5 terms, which is increased problem solving skill, and then we can benefit of innovation, we can help the student creativity and increase the innovation. And then the third one is promoting student vocation. And then 4 is developing student self-efficacy and behavioral intention. And last one, promoting 21st century skills and also STEM career interest. So this is for the objective 1. While for objective 2, we try to explore the innovation of STEM in teaching and learning, we found out two categories, which is teaching using the technology and teaching using the hands-on module. Which the teaching using hands-on module, they focus it on the pedagogies that can help the student to implement STEM education. For example, here is problem-based learning. According to Sue, KD, and also Sue Smith et al. 2022. While for the teaching using technology, we found out 2019 until 2023, so many innovation in STEM education using the technology, such as online interactive learning, interaction using the IoT, and also using the module fuzzy, using an aerial vehicle, virtual reality, robotic platform, and digital-based virtual classroom. So these are so many innovation that we found out from our research using the systematic literature review. So what we can conclude here, where the first one, the benefit of innovation, which is uh, creative thinking, creative thinking and innovation, problem solving is the benefit when we implement STEM education and to innovation things. And then so many innovation that the researcher made, which is focused on the module to help the teachers teaching STEM education effectively. And many of them is using the technology. Okay. So we can see here, actually just for our view, which is this is Global Innovation Index ranking, and then this is the world Global Innovation Index. So the innovation index, we can see. I just want to highlight lah the world in the world. So the country that is very good in innovation, which is Switzerland, US, Sweden, United Kingdom, Netherlands. This is the country that is good in innovation. Innovation. Where is Malaysia? Malaysia is at 36, very low in this global index. So maybe we this one maybe we need to implement teaching and learning so we in STEM education, so we can nurture the innovation in our student, and we can make our country ups, maybe Malaysia ups, maybe same level with Singapore, maybe same level with Korea, that we all always like the Korea fantastic Korea, maybe. Okay, so now I will share with you the practice of innovation in STEM in UTM, actually in our place, which is innovation in STEM education at UTM. Okay, so in innovation culture in UTM, maybe we put the STEM approach actually in the teaching and learning. And we also, in my place, our faculty, innovation is actually as a subject. And then also, we do innovation activities with the communities. This is in UTM, where we implement the STEM approach in teaching and learning. We have NALI, New Academia Learning Innovation Models. We have the framework, which is the framework that NALI is actually the framework that includes student-centered learning and blended learning. We call it the blended learning, combination active and systematic learning. And also, actually, this is the strategy. Case study teaching, problem-based learning, scenario-based learning, job creation. This is all the STEM approach in teaching and learning. Okay, we use the scenario-based learning. This is the 4 step of scenario-based learning. And then we also, this is, for example, how we need to have the scenario in the class, and then ask the student to do that. This is called the scenario-based learning. And then maybe I think we all know this problem-based learning. We always implement this in the class. problem-based learning, using the problem, using the fila chart, solve the problem in the group, and then presentation, the solve problems. And then this is the must do model of teaching and learning, which is inquiry, 5E. I think all of us already know this is 5E, maybe now it's 7E. With engage, explore, explain, elaborate, and evaluate. And then also in UTM, we have the service learning. We understand the problem, community as the learning lab, encourage to solve the problem, opportunity to learn with students, the real world problem, short and long term vision. So this is we have in our place innovation as a subject. So we have a subject in for maybe S2, I don't know, maybe S2, which is masters. So each of the student must have this subject, must have, this is a compulsory subject. So in this subject, the student need to innovate something module or something that can make the teaching and learning improve. Maybe the subject or the concept that we want to teach can be improved in the teaching and learning. Okay, so this is, we have the innovation day where the student have to create or invent or develop a product. And then we have this innovation day, we make we call it a pertandingan lah. This is all for the student. They need to present their work. And then we have the reviewer, and then we will review their models or modules they already make. And then we also have the community activities. We go to school. I think also have in News Negeri Padang. I think we already seen in Facebook. Dr. Budi always go everywhere doing these community activities. Okay, so innovation in STEM through engage with community. We are using the learning service learning. And then we have the maybe invitation from the communities, or maybe do it through research run. So we try to innovate to solve the community problem. And then this innovation in STEM with community. For example, we have Ask Dr. STEM. We have this is Superhero Simin Firo, Carnival Chemistry in Johor. And we also have the STEM Carnival to boost the innovation spirit in students. We have this is in our panels. We have STEM Caliph. We have innovation activities. We have STEM with technology. We have STEM Arduino. We have mathematics angels, city puzzle, rocket STEM, wind turbine. So many things that we do. Math angel, paper helicopter, catapult. This is all the activities that we try to create the innovation among the students. And we also have the workshop on STEM innovation with the teachers. So we do workshop with the teachers, STEM workshop, we do STEM with HOTS, innovation in STEM, game board. We also have the fuel workshop, maybe this is for green aspect, low carbon society, which is we use all to do maybe some solve with the student and the communities. We also doing the research to fostering innovation. Some of it we do in with the indigenous people. Which is we do the forest STEM, we do forest maths, which is especially for the indigenous people. And then we do STEM community. We have low carbon society in our group. In my panel, we also have a lot of things doing about low carbon society, and they also collaborate with our district or our some of our government agency. So they do something that with the low carbon society activities, and there are many things that they're doing, and now they can give some grant to the communities to do low carbon activity. This is the already third times activity that third times they give the communities a grant, but they need to propose a proposal lah, and then they choose which one is can be done. So they give them about maybe 15,000, maybe 10,000 to the community to create activity or to implement the community about low carbon society. And we also have the product, STEM product, which is maybe game board, which is using the robot. We also have the innovation we call module Quranic STEM with AR, VR, augmented reality and virtual reality. We also have community in STEM. We also pedagogy in STEM, and we also have the motivation in STEM, and also doing research on the philosophy of STEM, which is epistemology in STEM. Okay. This is some of the research example. This is the Quranic STEM, and we have the forest STEM. We have ikatan kina in Malay. So this is example, which is some of the module in our research. If we develop a module, for example, this one, we follow. If we develop module, so this is we choose a model of teaching and learning. We choose, for example, this is project-based learning. So there is 5 steps in the project-based learning. So we create our module based on the 5 steps in the project-based learning. So for example, this is the project-based learning model with the application of Al-Quran. This is the Quranic STEM. So this is some of the module that we develop. So we give them problems, and then the student need to come out what actually the concept in the problems they need to solve, and then they need to plan to do a research, to do a experiment, and then they try to do the experiment, and they need to fill in actually what they need to do the observation. So they need to fill in this part, and then we have after the usually if the student doing experiment, this is actually the part they will miss. They love, actually the student always love to do experiment and activity STEM, but actually they don't know actually what are they doing. So with the our research, we put some after they doing the experiment, and then we scan this one using AR or VR, augmented reality or virtual reality. They scan this one, and then they do the experiment back using the AR or VR application, and then we give them the what actually the concept will the concept behind the experiment. We visually, for example, here we give the ice cream, how to do the instant ice cream. So we show them the part of atom particle. So the particle, when the particle in liquid, in what arrangement, and then after a few we put some salt and ice, and then it will reduce the temperature, and then what happened to the arrangement of particles. So we showing in the AR. Okay, and then after that they need to maybe give back actually what they already learned. So same lah after doing the experiment. But in this, the best thing that we try to visual to them what they don't know, what they can't see actually after doing the experiment. Okay, this is the augmented. This is the that I already said just now. Okay, so the students scan, and then they need to do ice cream back, and then we show them the particle arrangement of the particle when when beginning, and then after that we show, and then we put some the concept of science there, and then in here we just put the verse of Al-Quran that relevant to this concept. So this is some of the research innovation in STEM. Research for ini also research for this is I said just now for the community and for low carbon society. We collaborate with government, community, government agency. We can give them money, and and then the community do themselves, do the project themselves. For example, they have for field lah, for education, for infrastructure, and for the waste, and one more thing I can't remember. So this is from our part lah. Okay. That's all. I think this is I can conclude in my presentation, which is innovation in STEM education. Equip the student with the various skill set, and then actually it can produce the actually we want to produce the innovation generation, and also can help this to solve the real world problem. Okay, that's all from me. I back to you, Miss Chairperson. Thank you.
You're welcome. Thank you very much, Dr. Niza, for this outstanding speech about STEM education. Okay, we will go to the next session, question and answer with audience. Maybe the audience attending this room, anyone who has question, please raise your hand. Yes, please. Bali. Right, while waiting for the questions, I just want to make sure that I got the point of your presentation. There are two key words for this presentation, two different words, but maybe they are related one another. STEM and innovation, right? Innovation is something that is really demanded by all of the nation, by all of the people to step forward for the next generation. And STEM is also, as far as I know, is an innovation never been left behind by educator at school, right? So what comes first actually? Is this the innovation that comes first, or maybe they work concurrently one another between the innovation and the STEM?
Okay, thank you, Miss, for the question. I think first, innovation is actually a very big issue, I think, because innovation, we can say so many things about innovation, because innovation is something that can make our life more easier, more practice, and more many things lah about the innovation. But in STEM education, for my presentation, we focus on developing innovation, how innovation in education, how the innovation is important in STEM education. Because in STEM education, we can see actually the now we are having problem in the world actually. For example, global warming, all the SDG problems. This is all related to our STEM education. That's why we need to emphasize the innovation in STEM education to make our problems that we faces now can be solved, and we can have the world maybe now is very in the global warming, we can see the world more becoming sick. Can so with the help of STEM education, where the STEM education can enhance innovation, what we call it, innovation culture in our students. So maybe it can help to make our world happy again lah. World happy again.
So we need innovation to implement STEM education, and STEM education can also foster innovation of the students, right? So they work concurrently. All right. The next question, you said about innovation as a subject and as an approach of learning. All right. In terms of innovation as a subject, can we say that innovation can be taught to students? Because like we all know, subject is something that can be taught to students. Students can learn the content within the subject.
Okay, thank you, Miss. In our okay, in our place, we make innovation as a subject because we are teachers. So this is not in the school, but it is for master's program, for the curriculum for master's program. We put the innovation as a subject. So in any subject or any program that enroll in as a master's in our university, our faculty, they need to take this subject, which is innovation. That's because we think that innovation is a very important thing for all the subject. So we develop the curriculum that we want to nurture the innovation in the teachers, actually. So that's why we create a subject that have the innovation. So in this subject, the teachers will be exposed to how to do the innovation in teaching and learning process. For example, they need to try to develop a module, maybe or maybe in teaching and learning, or maybe an apps that relevant to their course. Maybe he is a teacher, geography teacher, or he is a Malay teacher, or anything. So especially for STEM teachers, they need to develop something, they need to innovate something to make that subject or something, the problem in the area to be solved. Okay, for example, if the teacher is STEM education, for example, she is a chemistry teacher. He is a chemistry teacher, so he attend this innovation subject. So he needs to think. First, they need to do problems. We will the student will exposed to with what we call the design thinking approach, or maybe we call using the instructional design model, or we call it RD. RD, for example, RD have analysis, design, develop, implement, and evaluate, right? So we need the student need to analysis first. The analysis, what is the problem in the teaching and learning, or in their area lah. Chemistry, for example, and then they need to try if they they already analyze what the problem. For example, the student have the problem maybe too many misconception in electrochemistry. So he will try. So this is the problem. So they think and in about to design. So maybe she think that he will try to make a module and using the uh, needle fees. Needle maybe because this is misconception. Maybe he said he will need to have a a module to teach the student using the NIDAM phase, the 5 phase. So because NIDAM 5 phase, maybe it's designed to help to cater the misconception of the student. So he will try to make the teaching learning for in electrolysis using the model of uh, Needham 5 phase, and then he will develop, and then he will implement to the school or a few classes, and then he will evaluate. So these things then the teachers will do in this innovation as a subject, and then after that they need to we have a day, we have that innovation day, which is maybe a competition for all the teachers that already have that subject, innovation as a subject, what they already invent. So this the day all the maybe all the lecturer will choose the reviewer. They need to present, and they need to describe lah what actually the best thing of their projects, and then we will review, and then there will be a winner lah, the gold winner, the silver winner, and also the bronze winner. So this is to encourage them to do the innovation in teaching and learning process.
Encouraging innovation in the teaching learning process or in education in general is very important, right?
Yes.
So I'm interested on the proverb, if I can say that, don't be afraid of being failed, because when you do more and more, as long as you are in the right track, you may gain success at the end of time. So this is what I can interpret from your graph about the growth of mindset. Yeah, don't be afraid of failure. Take challenge and attitude to embrace the challenge, learn from the failure, and believe on self-power. So that's the way on how to be innovative in our practice. Can I say like that?
Yes, can.
Okay.
Yes.
All right. Thank you very much, Dr. Niza, for this enlightening speech about STEM education. May we get better in our teaching practice to develop innovation into our students. Okay, this is the end of the session for Dr. Niza. But before we end this session, there will be a handover of the placard. I'm sorry, handover of the certificate from the committee to the keynote speaker, Dr. Noor Hazniza Ibrahim. So this is your certificate. Can you see?
Yes, thank you so much.
Thank you. You're welcome. Nice to talk to you. Nice to have from you. See you in the next event.
Okay, thank you so much. Thank you, everyone.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okay, all right, audience, maybe we can take a 5 minutes break before we continue to the next session. Our last keynote speaker has been here. He is our lecturer and researcher at our university, Universitas Negeri Padang. While waiting for his
coming to the front stage, you can take break for about five minutes. Okay. Are you ready, Professor? Okay. So please welcome Professor Dr. Mawardi, MSI. Okay. Before we begin, I will share to you, the audience, the profile of our last keynote speaker. Professor Dr. Mawardi, MSI, is a lecturer, a researcher, and head of Deputy of Society Service Center at Universitas Negeri Padang. He has been teaching here at Universitas Negeri Padang since 60 years ago. So no wonder that he has a lot of experience, professional experience, research and awards from our institution and from national organization. Maybe we take a break while listening to them.
Yeah.
Okay, we continue. Professor Dr. Mawadi has expertise on Tanah Napa and Portland composite cement. He's also interested in educational area. Indeed, he has many research grants on education in flipped classroom learning, in guided inquiry learning, and in many other topics. Today, he's going to talk about chemical multiple representations in chemistry learning. So, are you ready, Professor Mawadi? Okay, so
Okay.
the time is yours.
Thank you. Bismillahirrahmanirrahim. Good afternoon, ladies and gentlemen. Thank you for your time today to join this second great event ICChSE 4. And also would like to say thank you for event organizer because of you are dedicated this event can be held properly. Ladies and gentlemen, my name is Mawardi from Universitas Negeri Padang. Today, in this is a great moment to talk in front of you to think that gone change how learning process must be, especially in chemistry learning. We will talk chemical multiple representation in chemistry learning. Chemistry composes many abstract concept and topic. For many studying, chemistry is seen a difficult, complex, and abstract subject. Requires special intelligence, talent, and too much effort to be understood. However, perhaps more than other science, understanding chemistry relies on making sense and invisible and untouchable. The direct introduction approach to concept formation shape metal on metal, non-metal, polymer subset, toxic substance, difficulties concept formation occur from some concepts like atom, element, compound, orbital shape, type of bonding, internal crystal structure, family of functional group. Let's consider our terminology regarding some distinct. If we see table predict, are you element symbol? Are you say element symbol, atomic symbol, or chemical symbol? Which question is correct? Which is stronger reduction oxidation agent, Fa or Cu? With strong reduction agent, Fa2 plus, I will replace this Zn2 plus or Cu2 plus. This talk based on book, teacher, lecture, everyday, daily experience. Is the question above correct? Proton in atomic nuclear or proton constituting two atomic nuclear? Di dalam bahasa Indonesia, apakah kita menyebut proton dalam atom atau proton penyusun atom? Next, when describing chemistry phenomena, chemists generally present concept three level of knowledge: representative, microscopic, submicroscopic, symbolic. We know all, yeah. Need not no knowledge. Yeah, the macroscopic level, submicroscopic level, and symbolic level. Next. This representasi star chemical phenomena by Jebel 1999, dan kemudian Johnston, student must understand the knowledge at three level of representation. We know multiple representation and we know chemistry triangle. Kemudian next Devetax develop the interdependent of three level science concept, model and order, explain the connection between concrete and abstract level. This we call mental model. Three level representation in chemistry: macroscopic, microscopic, and username molecular, atomic, submicroscopic, theoretical representation, and symbolic. This picture solution dissolution of NaCl, representation symbolic, kemudian and macroscopic image, molecular image. Next. Okay. In picture, ice, water, in water vapor. Based this picture, if we observing and understanding the picture, try to explain why does water fall in a very conditioner? A very conditioner, why this product as a water, produce as a water. What come from? Kemudian if we add ice to glass of water, where does the wall of the glass get wet? Asupan in LPG gas cylinders are solid, liquid, or gas. Our question will be answered if someone have good model mental based this picture. Next. This periodic table of element. Can we see argon? Argon, atomic number 18. If we look it with Niels Bohr's atomic, next. Niels Bohr atomic. That mean one atom argon have as 18 proton and 18 electron. Thus, we can conclude the Newton is more critical than atomic symbol, not element symbol. Because element contains some more atom argon. So, jadi we will call atom symbol, not element symbol. If we think this representation. Next, Niels Bohr atom model. We usually estimate species which can be oxidizing or reduction agent, or can under to auto-redox reaction. By observing Niels Bohr atomic model, for example, sulfuric acid. Sulfuric acid, if we observe electron configuration of sulfur, we can understand species can act as oxidizing and reduction agent. Can also auto-redox reaction. Why? Yeah. If we analyze this picture, we bisa memahami ya bahwa sulfuric acid can oxidation and reduction agent and undergo under auto-redox reaction. Next. Next. Okay. Yeah. Misconception about quantum number of electron. By observing and understanding following quantum mechanical atomic model, determine the 4-electron quantum number of the last electron of the nitrogen atom, which has atomic number 7. Yeah. Principal quantum number, azimuth quantum number, magnetic quantum number, spin. Yeah. We answer to next session. Yeah. Next. Last. Next. Voltaic cell. If we analyze vector voltaic cell, we not have data what about anoda, cathoda, negative, positive, current of electron, and so on. Please, which electron is anoda? Who is cathoda? How about we know that? Yeah, take picture. But how we can answer which anoda, which cathode. And how is the set of each electrode? Left electrode, right electrode, what is set? Why we to determine that? Where to where the follow electron? If we analyze this like picture, where do the cation and anion move in the salt bridge? How we can to answer that? Why this happen if a right electron electroda, left electron anoda? Why? This answer it depend on more how someone, how student have representative macro, representative symbolic, and submicroscopic. Next, the level, the interference of three level of concept model is called model mental by the Petak at 2005 ya. Okay. Next, application of multi-representative chemistry and chemistry learning. It's possible for teacher to use create picture manual and teacher help student to interdependent the three level concept and boil their mental model. Please take a look this two student notebook below, left and right. We can see where student yang have a good model mental and poor model mental. Student with poor model mental tend to remember. He write wajib hafal, and student with right model mental, he tend to make noted in netbooknya. I think next, okay. Next one. Ini some literature, new literature for best learning experience. Ya, next. Kemudian okay, understanding the multi-representation and chemistry learning to solve chemical information help students use what they know in different way. When they see how this way like they can explain this better and get fewer idea wrong. Even from this sound good, many students find it hard to shift between this way. They usually get what's going on when they see thing with their eye, and when they see chemical symbol, but strongly with imagining thin particle and how they behave. There are different teaching tools like Teach Health, lab experiment, and physical model to help students get it. It's interesting that all the high school students seem to handle a chemical problem better than just starting college. However, a problem pop when teaching this idea because of exam stress teacher often given students to put a formula. This leads students to memorize step rather than really get the topic. Right, but that doesn't mean that truly get the science behind it better if students really gets the main idea first. Thank you.
Okay. Thank you very much for the speech given by Professor Dr. Mawari MSI. So no, it's such a fact that chemical multiple representations is not a new term, but it has never been updated up to present, right? So we go now to the next session, question and answer with the audience. Anyone who has question can raise hand. Okay. As we know, multiple representations really help students to understand and to interconnect the concept of chemistry. Right? But we have three levels of representation in chemistry: macroscopic representation, submicroscopic representation, and symbolic representation. Do you have data or previous experience about which part of these representations is difficult for a student, is considered difficult by the student, or maybe all of them?
I think the student not usually to analyze and interdependence masing-masing representasi. They are usually use as representation symbol and writing in notebook. And if the go to the laboratorium to experiment, that they get representation that not can explain why this that happened if they not uh, uh, use representation microscopies. Nah, in all books or textbooks, representative submicroscopies itu that's the explain with symbolic one page to explain what happened at macroscopic level macroscopic. But in representation microscopic, the student the same logic seperti miskonsepsi for quantum number one electron. If one student understand orbital p orbital h p x p y p z, then akan paham dia. Tidak mungkin hanya min 1 atau tidak mungkin hanya 0 dan tidak mungkin hanya plus 1, because the orbital px pz this are energy, same energy and same ya. Jadi it's same logic.
So among these three levels of representation, students are familiar with the symbolic one. They can write the equation for a reaction, for example, but they don't really understand what is happening at the submicroscopic level, because teacher used to give the reaction equation to the students, and students only need to memorize the equation. Yeah. So this is it is our responsible to acknowledge students with these three levels of representation in chemistry learning, right, sir? All right. I agree that multiple representations are very important in learning for all of us, students, teachers, and lecturers, of course. Maybe perhaps there are several misconceptions on students while processing the information or concept during chemistry learning. That may include us. Yeah. This is our responsibility to learn more chemistry through these three levels of representation, so that we as an educator, lecturers who teach prospective teachers, can bring or give exact or an appropriate concept to the prospective teachers to be delivered to the next student when they teach in their senior high school. Right, so this is very important terms for us, clinical multiple representations. The speech by Professor Dr. Nawadi is ended, but the session will continue with the handover of the placard and by Mr. Alizar, PhD. The handover of the placard to Professor Dr. Nawadi will be given by Mr. Alizar, PhD. So Pak Edi will replace Pak Alizar to deliver the placard to Professor Dr. Nawadi. Thank you very much for your speech. You may return to your seat. Dear audience, all of the keynote speakers have presented or delivered their speech in front of us. I hope that we can get benefits of attending this conference. We can get better in our daily tasks, in teaching, in doing research, and in doing our part as our function as part of our society. This is the end of the second session in the fourth international conference on chemistry and science education. Thank you very much. I'm sorry for any mistake and incompleteness. I give the task back to the master of ceremony. Assalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, back to me, Master of Ceremony. We come to the end of the first day of conference. We would like to thank you for your spending your time with us today. For your information, the parallel session will be held tomorrow at 7:30 a.m. until 1 p.m. Western Indonesia time. Thank you very much for all your attention. Wassalamualaikum warahmatullahi wabarakatuh.